So the next topic in modern physics is nucleus. Atomic structure we have studied, structure of atom. Clear? So in structure of atom what we have studied about different theories we have studied, J.J. Thomson's theory, Rutherford's, Niels Bohr. Then we have calculated some parameters, all that we have studied in atomic structure. Then we will study about the nucleus and its components. Clear? So nucleus consists of what? Nucleus consists of protons and it consists of neutrons. Clear? No? So protons, positively charged particles, they are having positive charge, and what is the charge of a proton? Proton ki enta charge untundi cheppandi. Charge of proton will be how much? Same, charge of proton and charge of electron both are same. So charge of proton is nothing but charge of electron. This is equals to 1.6 into 10 power minus 19 coulombs. So this is the charge of a proton, and same charge exists for a electron also. Clear? Similarly, mass of proton is how much? Mass of proton, I can say it is 1.6726 into 10 power minus 27 kg. So that is the mass of proton. Are you able to understand that? So in atomic mass units, if I want to write approximately 1.0078 atomic mass units. So that is the mass of a proton. Okay. In terms of atomic mass units, this many atomic mass units, almost equal to 1 AMU, 1 atomic mass unit. Slightly greater. How much? 0.0078 AMU. Slightly greater than 1 atomic mass unit. 1 atomic mass unit means 1, no? Mass of proton is slightly, very slightly greater than 1 AMU. Almost you can say it is approximately equal to 1 AMU also you can call it. Approximately equal to 1 AMU. Are you able to understand? And when compared to mass of electron, mass of proton is nearly 1836 times the mass of an electron. Okay. So when compared to mass of electron, mass of proton is how many times bigger? 1836 or 1837 times bigger when compared to mass of electron. So electron mass to compare just the immediately పెద్దగా ఉంటుంది. It means it is a very very small mass. No? Mass of electron is very very small. Are you able to understand? No? So mass of electron is how much? Mass of electron in terms of atomic mass units you can write 0.00055 atomic mass units. Very small. Okay. See the mass of proton 1.0078, but this is 0.00055 atomic mass units. So mass of electron is very small. Clear now? Similarly, if I want to write mass of electron in terms of kgs, I can write 9.11 into 10 power minus 31 kg. This is the mass of an electron. Okay. Similarly, now if I want to write about neutron, okay, neutron, this is a neutral particle. That is why it is given the name neutron. Neutral particle. What is meant by neutral particle? Neutral particle means it doesn't have any charge. Charge of neutron is not there. So it doesn't have any charge. Only protons and electrons, they are charged particles. Neutrons doesn't have any charge. Clear? So if I want to calculate the mass of neutron, approximately it is 1.0083 atomic mass units. So again you can say this is almost equal to 1 AMU. Almost equal to 1 AMU, but slightly greater than 1 AMU. So you can say almost it is equal to 1 AMU. Okay. And see, compare here the mass of proton is how much? 1.0078, but this is 1.0083. It means when compared to what you call proton, neutron is slightly heavier. Again you can say it is almost equal to the mass of proton. Almost equal, but slightly greater. Okay. And neutron, you can split into proton and some another particle also. Okay, ma? That we will study later. Okay. And if I want to write its mass in terms of kgs, mass of neutron can be written as 1.6750 into 10 power minus 27 kg. So this is the mass of neutron. Okay. Again you can compare here. Mass of proton 1.6726, but mass of neutron is 1.6750 into 10 power minus 27 kg. Are you able to understand? No? So these are about this the particles which are present inside the nucleus, proton as well as a neutron. Okay, make a note of to here. Number. So what is meant by atomic number? The number of protons present inside the nucleus. So it is not mass of protons. No. Mass of protons is not called as atomic number, or proton number also you can call. Just the number of protons. How many protons are present? 2 proton, 3 proton, 20, 30, 40. How many protons are there? That number is nothing but proton number, or you can call it as atomic number. And atomic number is represented by Z here. For example, if you take hydrogen, how many protons are there? Only one proton is there. For example, if you take a calcium, how many protons are there? Calcium, 20 protons are there. Are you able to understand? For example, if you take a gold, how many protons are there? Gold. How many protons? 79 protons are there. Okay, ma? So atomic number is nothing but number of protons. That's it. In electronic configuration, we take atomic number only, no? Okay, ma? Atomic number is nothing but what? Number of protons only. Number of protons which are existing inside the nucleus. Okay. So therefore, then we study about mass number. Okay, ma? So what is meant by mass number? Mass number, it is represented by A. Okay. So it is the sum of protons plus neutrons. Okay, ma? So or you can say total number of protons and neutrons, that is called as mass number. Are you able to understand? So for example, you count the total number of protons and neutrons which are present inside the nucleus. So that total number of protons and neutrons is nothing but mass number. For example, if you take calcium, atomic number is 20. Mass number may be some 40. Okay. So 40 means what? 20 protons are there, 20 neutrons are there. That is the meaning of it. Are you able to understand? And it is represented by A. So therefore, how to denote an element? Denoting of an element. How can I denote an element? So I can write X, A, Z. This is how I denote an element. Are you able to understand? For example, if I take carbon, so I will write atomic number here and I will write mass number here. Okay. So there are many isotopes of carbon. C610 is also present, C611 is there, C613 is there, C614 is there. That's all up to here. Are you able to understand? So these many isotopes of carbon is present. So all of them, they are carbon only. And what does 6 represent? Number of protons. If number of protons changes, element will change. Are you able to understand? If number of protons will change, element changes completely. 6 కాకుండా 7 రాసినారు అనుకోండి ఏమవుతుంది? It becomes nitrogen. Are you able to understand? So properties of elements depends on what? Properties of elements only depends on number of protons only. Are you able to understand? It doesn't depend on number of electrons, it doesn't depend on number of neutrons. Properties of element depend only on number of protons itself. Okay? Because unless it is 6, then only it becomes carbon. ఒకటి పెంచినారు అనుకోండి అది నైట్రోజన్ అయిపోతుంది, ఒకటి తీసేసినారు అనుకోండి అది బోరాన్ అయిపోతుంది. అర్థమవుతుంది కదా? That's it. But these are different isotopes. So C612 is also present. What is meant by C612? 6 protons are there, 6 neutrons are also present. 6 plus 6, 12. This is mass number. No? And again, what is meant by 610? 610 means what? 6 protons are there, only 4 neutrons are present. Because 6 plus 4, 10, like this. Are you able to understand? No? So therefore, this is the method of denotation. Here I have to write atomic number, here I have to write mass number. Is it clear? Okay. So then we will discuss about some of the very important types of elements called isotopes, isobars and isotones. Clear? No? So therefore, what is meant by isotopes? Isotopes means what? Elements with same atomic number, but different mass number. Okay, ma? Different mass number, they are called as isotopes. It means atomic number should be same, mass number should be different. Just now we have written an example, isotopes of carbon. If I take carbon 610, carbon 611, carbon 612, carbon 613, carbon 614. So these are some of the examples of isotopes. All of them you can call them as isotopes. Are you able to understand? Because their mass numbers are different, atomic numbers are same. Clear? Similarly, you can write hydrogen 11, hydrogen 12, hydrogen 13. Okay, ma? So actually this you can call it as hydrogen, and this one you can call it as deuterium, and this one you have to call it as tritium. Are you able to understand? So, but atomic numbers are same, no? 1, 1, 1. Mass numbers are different. So this is called as an isotopes. These are some of the examples of isotopes. Clear, no? So then we study about isobars. Okay. Isobars with means what? Elements with same mass number mass number is same but a different atomic number. Are you able to understand, ma? So mass number should be same but atomic number should be different. Such type of elements you can call them as isobars. Examples we will write here. For example, if you take the example of argon and calcium, okay, ma? Atomic number is 18, atomic number of calcium is 20. Its mass number can be 40 and its mass number also can be 40. Okay, mass numbers are same but atomic numbers are different. So this is one example of a isobar. Are you able to understand? Clear? Similarly, if I take sodium and magnesium also. Sodium and magnesium. Sodium atomic number 11, mass number atomic number of magnesium is 12. Mass number of sodium can be 23, mass number of magnesium also can be 20. So mass numbers are same, atomic numbers are different. Vivek, rasta unnava? Notes rasta unnava? Pending unte idu kuda pending pettukunte etla? Okay, that's it. So next we study about the third type of element which is called as isotones. Clear? Isotones means what? Elements with different mass number and different atomic number but same proton neutron number. Okay, ma? So this type of elements we can call them as isotones. Clear? So mass numbers are also will be different, atomic numbers also will be different, but a number of neutrons will be equal. So that type of element I can call it as what? Isotones. Okay, ma? So example of this one we will write here. Examples are, for example, if you take hydrogen 1,3 which is called as a tritium, helium 2,4. This is one example, no, ma? Okay. For example, if you see here 1,3, 2,4, 1 and 2 they are different. Atomic numbers are different. 3, 4 mass numbers are also different. But if you do 3 minus 1, what you will get? You will get 2. And what is this 2? This 2 is number of neutrons. That's all. From mass number, if you remove atomic number, remaining is number of protons or neutrons only, no? Clear, no? Similarly, 4 minus 2, then also I will get a 2 1. And what is 2 again? Again it is number of neutrons. So like this you can write many examples. Are you able to understand, no? So mass numbers also should be different, atomic numbers also should be different, but number of number of neutrons should be same. That is called as isotones. So these are some of the examples. Clear, no? Sometimes direct questions will be asked on them. Clear? So you should be careful about them. Okay. So then we study about atomic masses. Clear, ma? So atomic mass. Okay. So atomic masses are very small. Okay, ma? Therefore they are measured in what? They are measured in atomic mass units, AMU. Okay. AMU you can also call them as unified mass also. Okay, ma? So mass of, for example, if I want to calculate mass of proton, it's a very small value, no? You cannot measure it in grams or kgs. Gramలలో kgలో measure చేయాలంటే చాలా కష్టం. Clear, no? So we measure the masses in atomic mass units, which are very small units. Okay. Now what is meant by 1 AMU? We will write the definition of 1 AMU. Okay. So it is the mass of 1/12th of mass of C612 isotope. Are you able to understand, ma? So how I define 1 AMU, ma? Previously mass of hydrogen was taken as 1 AMU. Previously when we were studying, there was no concept of carbon. Then we were studying that mass of hydrogen is 1 AMU. But technically there were some problems, so they changed it to carbon. Okay. So 1/12th mass of C612. There are many isotopes of carbon, no? C6, 10, 11, 12, 13, 14 are present. Which isotope I have to take? That isotope whose atomic number is 6, mass number is 12. That isotope. So, and in that atom, how much part I have to take? Only 1/12th part of that one particular single atom. Okay, ma? So this is what? This is only one atom. One atom of C612. ఒక atomలో మళ్ళీ ఎన్నో భాగము? 12th part. 1/12th part if I take, then that amount of mass is defined to be 1 AU. Are you able to understand? So therefore, what is the mass of 1C612? Can you say? ఒక కార్బన్ ఆటం మాస్ ఎంత ఉంటుంది మరి? 1/12th mass of carbon C612 is called 1 AU. 12వ భాగాన్ని ఒక AMU అన్నాం. Then what is the mass of one carbon atom? 12 AMU. That's all. ఏమైతున్నారు మీరు? Okay ba? 12 AMU. Understood, no? Mass of 1/12th part is 1 AMU. మరి ఒక కార్బన్ ఆటంకి AMUs ఎన్ని ఉంటాయి? 12 AMU. That is the mass of one carbon atom. Are you able to understand, ma? Then we know molar mass of carbon or molecular weight of carbon. Molar mass of carbon is how much? 12 grams, no ma? Molar mass of carbon is 12 grams. So here the discussion is very, very, very important. Useful both in physics as well as in chemistry. So listen very carefully. So mass of one carbon atom is 12 AMU. Molar mass of carbon 12 grams. So what is the difference between AMU and grams? నిన్న కూడా మొన్న ఎప్పుడో ఈ డిస్కషన్ జరిగినట్టుంది ఆల్రెడీ. అర్థమవుతుందా? మాస్ ఆఫ్ వన్ కార్బన్, వన్ సింగిల్ కార్బన్ ఆటమ్ ఈజ్ 12 AMU. క్లియర్ నమ్మా? బికాస్ 1/12th మాస్ ఈజ్ టేకన్ యాజ్ 1 AMU. కార్బన్లో 12వ భాగాన్ని తీసుకుంటే దాన్ని ఒక AMU అనుకున్నాం. దెన్ వాట్ ఈస్ ద మాస్ ఆఫ్ టోటల్ వన్ కార్బన్ ఆటమ్? 12 AMU. అంతే కదా? ఓకే, అర్థమవుతుందా? ఉమేష్ని 4 భాగాలు చేసినాం, మర్డర్ చేసి. ఒక్కొక్క భాగం 10 గ్రాములు ఉందనుకున్నాం, మరి అంత తక్కువ ఉండండి. ఒక్కొక్క భాగం వచ్చేసి 3 kgs ఉంది, 4 భాగాలు చేసినాం. మరి మొత్తం మాస్ ఎంత ఉంటుంది? 4 3 12 ఉంటుంది, అంతే కదా? మరి అదే కాన్సెప్ట్ అంతగా ఆలోచిస్తూ ఉన్నారు. 12th mass of carbon is taken as 1 AMU. Are you able to understand, ma? Then what is the mass of total carbon? 12 AMU. Understood, no? So mass of single carbon atom is 12 AMU. Then molar mass of carbon 12 grams. You know this one already, no? In chemistry you should have studied, no? Molecular weight of carbon or molar weight of carbon is how much? 12 grams. Now what is meant by 12 AMU? What is meant by 12 grams? 12 grams means 1 mole. 1 mole means what? 6.0. No, 6.0. What is that? Huh? ఈ రెండింటికి డిఫరెన్స్ చెప్పండి చాలా. 12 AMU అంటే ఏమని? దిస్ ఈస్ ద మాస్ ఆఫ్ వన్ ఆటమ్. ఓకే, వాట్ ఈస్ దిస్ వన్? This is the mass of one atom. Molar mass means what? Mole means 6.023 into 10 power 23 atoms. It means if you take the mass of not single atom, how many atoms? Mass of 6.023 into 10 power 23 atoms of carbon if you take, then their total mass will be 12 grams. That is the meaning of it. అర్థమవుతుంది కదా? So therefore this is the 12 grams is the mass of how many atoms, ma? This is the mass of, okay ma? Mass of 6.023 into 10 power 23 atoms of what? C612. Okay, that is the difference. That is the difference between AMU and grams. If you are writing in AMU, it means that is the mass of single atom or single molecule. Okay, but if you are writing the same value in grams, then it means that you are taking the mass of how many atoms? These many atoms. Inni atoms mass kalipite oka molar mass అవుతుంది, and that is exactly equal to the same numerical value. ఇక్కడ 12 వస్తే ఇక్కడ 12 వస్తుంది. For example, if you take oxygen, what is the molar mass of oxygen? 16 grams. 16 grams. What is meant by 16 grams? You take the mass of 6.023 into 10 power 23 atoms or atoms of oxygen. Are you able to understand, ma? 6.023 into 10 power 23 atom, అన్ని atoms తీసుకుంటే వాటి మొత్తం mass will be how much? It will be 16 grams. Then what is the mass of single oxygen atom? 16 AMU. That's it. Are you able to understand, ma? That is the difference between AMUs and representation in grams. Clear? So therefore, for example, here I can write down. So mass of one atom of oxygen is how much? It is 16 AMU. Okay, ma? Mass of 6.023 into 10 power 23 atoms of oxygen is how much? It is 16 grams. That's it. That is the difference. Clear, number? Simon, grams is a very, very, very big unit when compared to AMU. AMU to compare cheste, grams is a very, very big unit, because AMU is the mass of single atom, but grams is the mass of these many atoms. Inni atoms mass తీసుకుంటే 16 grams. Okay, so to make calculations easy, so this number is taken 6.023 into 10 power 23. Why it is taken? so that there is some symmetry between AMU and grams. AMU నాట్ నంబర్ ఎంత ఉంటుందో గ్రామ్ నంబర్ కూడా అంతే ఉండాలి. అలా ఉండాలి అంటే డెఫినెట్లీ యూ హ్యావ్ టు టేక్ అవగాడ్రో నంబర్. దట్ ఈస్ వై ఓన్లీ దిస్ నంబర్ ఈస్ టేకన్ యాజ్ అవర్ స్టాండర్డ్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? దట్స్ ఇట్. సో దట్ ఈస్ అబౌట్ మాలిక్యులర్ మాస్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? ఓకే, completed not to here. So therefore what I have written, mass of these many atoms of carbon is equal to 12 grams. No? Therefore what I do, therefore mass of one atom of carbon C612 will be how much more? It will be equal to 12 grams divided by, now I have to multiply with, divide by which number? 6.023 into 10 power 23. So if I calculate this one, I will get mass of single atom of carbon. No? Are you able to understand? Single of atom of carbon, I know it is 12 AMU. Already I know this value. Okay. But now I am trying to calculate in terms of kgs and grams. Okay. So mass of these many atoms of carbon is 12 grams. Then mass of single atom of carbon, ఒక atom కార్బన్కి మాస్ ఎంత ఉంటుంది? 12 grams divided by this number, 6.023 into 10 power 23 grams. Okay. So this one, if I multiply by 10 power minus 3, then what happens? So therefore it converts into kgs. That's all, number. Because 1 gram is how many kgs? 1 gram is 10 power minus 3 kgs. So if I multiply this total value by 10 power minus 3, it converts into kgs. Are you able to understand, ma? So therefore, so this is the mass of carbon C612. Then 1 by 12th mass of C612 is called what? 1 by 12th mass of C612 is called what, ma? It is 1 AMU, no? Okay. So therefore this total value I have to divide by 12, no? This total value, if I divide by 12, then it is nothing but 1 AMU. That's all. So therefore what I do, 12 into 10 power minus 3 divided by 6.023 into 10 power 23 multiplied by 12, then it totally converts into kgs. Are you able to understand? Now if I do this total calculation, I will get it is 1.66 into 10 power minus 27 kg. Okay. So why I have done this total calculation? To calculate, to convert AMUs into kgs. Okay. 1 AMU is equal to how many kgs? These many kgs. 1.66 into 10 power minus 27 kg. Okay. And this is approximately mass of proton. And again approximately the mass of neutron also. And approximately the mass of hydrogen atom also. Are you able to understand, ma? Mass of proton is how much? 1.6726. Almost equal to 1.66. What is the mass of neutron? 1.6750 multiplied by 10 power minus 27. This is also almost same. So 1 AMU is almost equal to mass of proton, almost equal to mass of neutron, almost equal to hydrogen 1,1 isotope. Understood, no? That's it. So have you understood the calculations, ma? How we got to this result? Once you go through these steps carefully, then very easily you can understand. Okay. And these calculations are very, very important. Totally you understand the basics of AMU here. Okay. Otherwise you cannot do many problems of physics as well as chemistry also. Okay. అంటే న్యూటన్ పెళ్లి చేసుకోలేదు ఎప్పుడు. న్యూటన్ ఎవర్ మ్యారీడ్. సో బ్రహ్మచారిగా ఉన్నాడు అనమాట ఇప్పుడు. 83 years ఎంతో బతికినాడు ఆయన. ఆ వయసు వరకు కూడా హీ రిమైండ్ టు బి బ్యాచులర్. సో బ్రహ్మచర్యం వహించిన వాళ్ళకి ఆ ఇంటెలిజెన్స్ లెవెల్స్ని ఎవరు తట్టుకోలేదు. అది చాలా ఎక్కువగా ఉంటుంది. Are you able to understand? Once a person starts practicing this బ్రహ్మచర్యం, లేడీస్కి ఆప్షన్ ఉండదు. మీరు బ్రహ్మచర్యం పాటించినా పాటించకపోయినా మీకు అంతే ఉంటుంది. క్లియర్గా? దట్ ఈస్ ద గిఫ్ట్ ఓన్లీ ఫర్ మేల్స్ ఓన్లీ. సో వన్స్ దే ప్రాక్టీస్ దిస్ థింగ్, దర్ ఇంటెలిజెన్స్ లెవెల్ బికమ్స్ మల్టీఫోల్డ్. 2, 3, 10, 20, 100 రెట్లు పెరుగుతాయి. సో దట్ వాస్ ద ప్రాక్టీస్ ఆఫ్ న్యూటన్. సో దట్స్ వై దెర్ ఈస్ నో బ్రాంచ్ ఆఫ్ సైన్స్ ఇన్ విచ్ హీ డిడ్ నాట్ ఎంటర్. మ్యాథ్స్, ఫిజిక్స్, కెమిస్ట్రీ, బయాలజీ ఏది పడితే దాంట్లో దూరేస్తాడు ఆయన. అండ్ ఆల్మోస్ట్ ఆల్ ద ప్రిన్సిపల్స్ ఈవెన్ దే ఆర్ కరెక్ట్ టుడే ఆల్సో. So he is considered to be the most intelligent, and next person is Einstein in total history of great people of scientists. Clear now? So Einstein's mass energy equivalence. See, he derived a very beautiful relation and one of the most easiest as well as toughest relation. The relation is very easy because just it can be written is equal to mc squared. Very easy to use, no? But where we use this one, this is very tough. Okay. So he said that mass and energy are, how can you say, are one and the same. Okay, ma? It means that mass you can convert into energy. Energy also you can convert into mass. Are you able to understand, ma? Mass ni meer energy ga marchochu, energy ni kuda mass ga marchochu. So therefore he did not differentiate between mass and energy. Mass is a form of energy or radiation. Light is a form of energy, no, ma? Light is a form of mass. Mass, if you can light, if you can condense it, you can convert it into mass also. But methods of conversion we don't have. But some scientists, they proved it also. So continuously they incident some radiation on a particular metal, then they counted the number of electrons. Then after some time they found that the number of electrons have increased. Okay, ma? It proves that light energy also can be converted into mass. But suitable means and methods we still don't have. Are you able to understand? So mass and energy, they are interconvertible. That is the statement which was given by Einstein. Clear? So therefore here, in terms of nucleus, we can say that M is the mass disappeared. Okay, ma? M is what? M is the mass which has disappeared. For example, if you take carbon nucleus. Okay, ma? Carbon nucleus is made up of what? Carbon nucleus lo em untayi cheppandi. There are many small particles. Major particles are protons and neutrons. There are many other particles also which doesn't have considerable mass. Are you able to understand, ma? So 6 protons will be there and 6 neutrons will be present in C612 isotope. And if you count the masses of protons individually, mass of protons if you count individually and mass of neutrons if you count individually, how many protons are there? 6 protons and 6 neutrons individually. Are you able to understand? And you take the mass of carbon nucleus. In carbon nucleus also how many protons are there? 6 protons are there, 6 neutrons are there. But mass of this combined nucleus, it is always less than the individual particles. అర్థమవుతుంది కదా? ఇండివిజువల్ పార్టికల్స్ మాస్ తీసుకుంటే కార్బన్ న్యూక్లియస్ మాస్ ఎప్పుడు తక్కువగా ఉంది. ఇట్ మీన్స్ సమ్ ఆఫ్ ద మాస్ హ్యాస్ డిసపియర్డ్. నో, సమ్ ఆఫ్ ద మాస్ హ్యాస్ డిసపియర్డ్. అండ్ వాట్ హ్యాపెండ్ టు దట్ మాస్? So that disappeared mass has converted into energy. That is the statement which was given by Einstein. Are you able to understand, ma? For example, so that we will discuss in mass defect, ma. Now here we will limit our discussion up to here. So M is called what? M or delta M is called as mass disappeared, and E is called what? Energy converted, energy obtained. Energy obtained you can call it as. Clear? And C is called as speed of light. C is called as speed of light, which is 3 into 10 power 8 meters per second. Are you able to understand? So it means if some of the mass disappears, it converts into energy. And how much energy will be released? E is equal to mc square energy will be released. Okay. Let us do a small calculation. So if 1 gram of mass is converted into energy, find energy released. Find energy released. Are you able to understand? If 1 gram of mass, if I can convert into energy, then how much energy will be released? Which equation I can use? Same, E is equal to mc square. So E is equal to mc square. So E is equal to mass is how much, ma? 1 gram. But if you want to convert into kgs, 1 into 10 power minus 3 kg. Because every value I should take in SI units only, no? And C means what? Speed of light, 3 into 10 power 8. And C square is there, no? So 3 into 10 power 8 whole square. So therefore how much it is? So 1 into 10 power minus 3 multiplied by 9 into 10 power 8 2s are how much, ma? 3 square, 16. Are you able to understand? So therefore it is 9 into 10 power 13 joules of energy. Okay. So how much energy is released, ma? 9 into 10 power 13 joules of energy. Small energy or a very, very big energy? It's a very, very huge amount of energy. Okay, ma? So this much amount of energy can be released if you can convert 1 gram of matter into energy. That's it. Clear? Similarly, if 1 AMU, which is equal to 1.66 into 10 power minus 27 kg, is converted into energy, clear, no? Then 931.25 million electron volts of energy is produced. Okay, ma? So this is a very, very, very important point. Okay, 1 AMU, it is also mass only, no? 1 atomic mass unit. Okay, and one atomic mass unit is how many kg? 1.66 into 10 power minus 27 kg. 1 AMU of mass, if I convert into energy, then how many electron volts of energy will be released? 931.25 million electron volts. So million means 10 power 6, or you can call it as mega also. 931.25 into 10 power 6 electron volts of energy will be released. Are you able to understand? This is called as mass energy equivalence, a relation between mass and energy. Okay, nucleus. See my size of nucleus depends on what? Depends on mass number. This is understandable, no? Okay, no? Mass number depends on number of protons and neutrons only, no? So if mass number increases, automatically size of the nucleus also increases. Size of nucleus of hydrogen is very small, because only one proton will be the neutron. In hydrogen 1 you don't have a nucleus, a neutron also, only proton is present. Similarly, if you take argon, atomic number 18, clear number? So 18 protons are there, nearly some 20 neutrons are there. Are you able to understand? 20 or 22 neutrons are there. Similarly, if you take gold, inside gold nucleus, how many protons will be there? 79 protons will be there, and very huge number of neutrons also will be there. Are you able to understand now? Class start everything is fine, no problem. No problem. Okay. So see, as atomic number increases, number of protons will be greater than number of neutrons will be greater than number of protons. So atomic number perige koddi. For example, if you take zinc, okay, 30 what you call protons are there, but the number of neutrons are greater than 30. Are you able to understand? So because as more number of neutrons increases, stability of that nucleus also increases. Are you able to understand? So therefore, what we are writing here, size of nucleus depends on mass number. As mass number increases, size of the nucleus also increases. So size is nothing but nucleus is a spherical type of body, nama. And what is the formula for volume of a sphere? 4 by 3 pi r cube. This is the equation for volume of a sphere. So this is directly proportional to A. A means what? Mass number. A and atomic number gadako, mass number. Are you able to understand? Ma? Therefore, I can write r cube is directly proportional to A. So r is directly proportional to a power 1 by 3. Okay, ma? Or I can write r is equals to r naught a power 1 by 3. This is the relation. Okay, where r naught is a constant. Okay, ma? And its value is 1.2 into 10 power minus 15 meters. So by using this equation, you can calculate the radius of any nucleus. R means radius here. Are you able to understand? Ma? In some of the books, it is written in capitals also. Capital R is equals to r naught a power 1 by 3, where this is equals to r. R naught is a constant, and its value is how much? 1.22 into 10 power minus 15 meters. So this is the equation by which I can calculate what? I can calculate radius of any nucleus. Understood? Radius of nucleus, if you want to find out, then this equation you can calculate. Okay. Similarly, you can calculate the density also, density of nucleus. Okay, and the formula of density is equals to mass by volume. No? Density is equal to mass by volume. Mass means what? I can write m into A divided by 4 by 3 pi r cube. I can write like this. Listen very carefully. What is m here? Mass of total nucleus. Mass of total nucleus, how can I calculate? Ma? A means what? Mass number. It is just a number. Adoka number matrame, mass kaadu kada adi. And mass means, here A means what? Here A means number of protons plus neutrons. Clear, no? Number of protons plus neutrons is called as A, mass number. And number of protons and neutrons, I can call them as nucleons also. Nucleons. Okay? And mass of proton and neutron, almost they are same, no? Mass of proton and neutron, almost they are equal. Neutron is slightly bigger than proton, but slightly, very slightly. So, instead of protons and neutrons, just you can write nucleons. Nucleons means you will get the protons also, you will get neutrons also. Are you able to understand? And m is what? M is approximate mass of nucleon. Approximate mass of nucleon. So what is the mass of proton? 1.6726. Mass of neutron? 1.6750. Approximately you can write 1 AMU nama. Approximately you can write 1 1 already we said no, 1 AMU is almost equal to 1 mass of proton or 1 mass of neutron. And 1 AMU is how much? 1.66 into 10 power minus 27 kg. Okay. So therefore, if you take this value and if you substitute here, then you will get the density of the nucleus. Are you able to understand? So see here, I will write. Okay. So density is equals to mass. Mass is how much? 1.66 into 10 power minus 27 multiplied by mass number divided by 4 by 3 pi. And instead of r, I can write r naught a power 1 by 3 no? This also I can write no? So multiplied by r naught a power 1 by 3 whole cube. Clear no? So therefore again if I do this calculation, 1.6 into 10 power minus 27 multiplied by a divided by 4 by 3 pi multiplied by r naught cube multiplied by a. So a and a get cancelled. Okay. And r naught is a constant no? And what is the value of r naught? 1.2 into 10 power minus 50. So therefore if you substitute that value, 1.66 into 10 power minus 27 divided by 4 by 3 pi multiplied by 1.2 into 10 power minus 15 whole cube. Okay. If you do this total calculation, then I will get approximately 2.17 into 10 power 17 kg per meter cube. Okay. Let me check it whether it is correct or not. 2.3 into 10 power 17 kgs per meter cube. So this is the density of nucleus. Understood no? So see, the density is small or very big or very very big. Density of water is how much? Density of water is only 10 power 3 kg per meter cube. Okay. Water em baro takke barve undadu kada water 10 power 3 kg per meter. But see the density of nucleus, 10 power 3 akkada, 10 power 17 akkada. So the density of nucleus is very 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 big. Okay. But density of atom is very less. Why? Because nucleus, though it is highly denser, it is a very small particle, no? And atom is mostly empty. That's what we studied in the last class. No? Atom is mostly empty. Size of atom is only because of rotation of electrons. So if you take overall density of atom, it is very less. But density of nucleus only if you take, then it is very very large. If you consider nucleus in the nucleus undanukondi, for example, దాన్ని ఒక 1000 మంది కలిపినా లేపలేరు. Just ఇంత size nucleus ఉందంట, because its density is very large. Are you able to understand? So that is about the size of nucleus and density of nucleus. So remember up to here, then we will continue in the next. Okay, no? So he is asking us to find out the nuclear radius of lead and oxygen. Clear now? So yesterday what was the equation which we have studied to calculate radius? R is equals to R naught a power 1 by 3. This is the equation. So just substitute in this value for lead. Okay, no? R is equals to R naught value is 1.2 into 10 power minus 50. This already we have calculated. No? Multiplied by A means mass number. What is the mass number of lead? 208 power 1 by 3. So just do this calculation. That will be the radius of lead atom. Are you able to understand? Lead nucleus. Okay. Similarly, for oxygen also you can calculate. Okay. So again R is equals to R naught a power 1 by 3. R naught is 1.2 into 10 power minus 50 multiplied by mass number of oxygen is 16 power 1 by 3. So just do this calculation. Clear now? And these values you can take approximately now. Okay. For example, you can take 5 5 0, 25, 25 5 0, 125. So you take 6 6 6 0, 36, 36 6 0, 190 something you will get. Okay, approximately you can take this value of 16 point something. Okay. So this also 2 2 0, 4 4 2 0, 8, 3 3 0, 3 3 0, 9, 9 3 0, 27. So it will be between 2 and 3. Are you able to understand? Like that you can take approximately the values. Okay. So the final answers which he gave is, for lead it is 7.1 into 10 power minus 15. 7.1 into 10 power minus 15 meters. And for oxygen it is 3 into 10 power minus 15 meters. 3 into 10 power minus 15 meters. So these are the answers. Okay. Defect. So what is meant by mass defect? Yesterday also I think we have had a small discussion on this one. See. So if I take mass of nucleus, nucleus means it contains protons and it contains neutrons. So I take the mass of nucleus now. Are you able to understand? Then after that, then I will take the mass of individual nucleons. What is meant by nucleus? Protons and neutrons, they are called as nucleons. So individually if I measure the mass of nucleus, or if I take combined mass of nucleus, then I see that combined mass of nucleus is always less than if I take the mass individually. So some mass has disappeared when nucleus has formed. So that disappeared mass itself is called as mass defect. Are you able to understand? See, for example, how can I calculate mass defect? Delta M can be written as, so Z into mass of proton plus N into mass of neutron, if you add both of them individually, minus of total mass of nucleus. If I take, then always there will be some difference. That difference is nothing but mass defect. Are you able to understand? Now can you say what is meant by Z into MP? MP means mass of protons. Clear? Z into MP means? Z means number of protons, not atomic number. So you take the total mass of individual protons separately. Okay, we know what is the mass of one proton? No? 1.0078 atomic mass units. That is the mass of one proton. So you take the mass of all the protons and you take the mass of all the neutrons. So N is number of neutrons. M is number of mass of the neutron. So you take the masses of individual nucleons. Okay. Then you take the mass of combined nucleus. Okay. Then I see that this mass is always greater than combined mass of the nucleus. Are you able to understand? It means when these particles, when they combine to form a nucleus, some mass is disappearing. Some mass is completely disappearing. That disappeared mass is nothing but mass defect. Are you able to understand? So now first of all make a note up to here. చెప్పేటప్పుడు రాసుకుంటా ఉన్నారు ఇది మీరు చెప్పేటప్పుడు వినాలి కానీ రాసుకుంటే ఎట్లా? In helium nucleus, how many protons are there and how many neutrons are there? So there are 2 protons and there are 2 neutrons. Are you able to understand? So what I do is, so mass of individual particles I will take. Mass of individual particles. What is meant by mass of individual particles? So 2 into mass of protons plus 2 into mass of neutrons, because there are 2 protons and there are 2 neutrons. Okay. So let us call it as total mass as M1. Are you able to understand me? Then what I will do, I will take the mass of helium nucleus. Okay. So inside helium nucleus also we have 2 protons and 2 neutrons only. No? Okay. Now take mass of combined nucleus. Okay. And let its mass is M2. So actually we believe that M1 and M2 they should be equal. No? Mass of individual particles is M1, 2 protons plus 2 neutrons. Combined mass is M1. And if you take mass of nucleus, nucleus of helium also contains 2 protons and 2 neutrons only. No? So its mass is M2. But when I check their masses, I always see that M1 is greater than M2. Individually if you take masses, then it is M1. Nucleus lo kuda ave untayi kada, inside nucleus of helium also you should have 2 protons and 2 neutrons. Mari masses same ga undali kada. Are you able to understand? But I see that the individual masses, that is if I take the masses of protons and neutrons separately, then it is always greater than when the same protons and same neutrons when they combine to form nucleus. Nucleus form అయినప్పుడు వాటి masses M2 గా ఉంటుంది. And I see that M1 is always greater than M2. Okay. So this difference of M1 and M2, this difference is nothing but mass defect. Okay. So what happened to that remaining mass? That remaining mass, it has been converted into energy. Are you able to understand? So therefore what I say, this mass defect or reduced energy, reduced mass, okay, has converted into what? Has converted into energy and is being released. Okay, that mass has been converted into energy and it is liberated. Okay. See, whenever particles, when they lose some energy, they become stable. Are you able to understand? This is not the property of just nucleons only. This is the property of any body in this universe. If body has more energy, it will become more unstable. So when some of the mass has converted into energy, and when that energy is liberated into the atmosphere, then the same nucleons, they will become stable. Are you able to understand? See, inside the nucleus, 2 protons are there. No? Protons are which kind of particles? Positively charged particles. So one proton is present beside another proton. Rendu protons ఒకే చోట ఉన్నాయి కదా. So even though there is a very strong force of repulsion between them, between one proton and one proton, force of repulsion ఉంటుంది కదా. So even though there is a lot of force of repulsion, but still they are present at same position. It is only because of this mass defect. Are you able to understand? Some of the mass has converted into energy and it is released. So when these protons and neutrons, when they lose some energy by converting some of their mass into energy, they become stable. Are you able to understand? So stability is obtained only because of release of energy when they lose some energy. Okay, let us try to understand this one in general terms. Clear ma? Jyoti ki ₹1 crore ichchanu. I have given 1 crore of rupees to Jyoti. Evaru Jyoti meelu? Clear ma? పొరపాటు అయిన క్లాస్లో కూర్చుంటుందామా? She'll never sit in the class. Are you able to understand ma? She will become more and more unstable. ఓకే, సంవత్సరానికి లేదా వారానికి ఒక రోజు క్లాస్కి వస్తుంది, మిగతా రోజులు మట్క ఆడడానికో లేదంటే క్రికెట్ బెట్టింగ్లకో ఏదో ఒకటి వాడుకుంటుంది అనమాట. క్లియర్ నౌ? షీ విల్ నెవర్ బీ ఇన్ ద క్లాస్. ఓకే, బట్ ఆఫ్టర్ టోటల్ 1 crore of rupees is completed, then what she will do? She will become more stable and మర్యాదగా వచ్చి క్లాస్లో కూర్చుంటుంది అనమాట. క్లియర్ నౌ? Same concept is happening with the case of these nucleons also. When they have more energy, they are unstable. So what they will do is they have to release some energy. And how they can release energy? Because Einstein said that mass and energy, they are interconvertible. No? So they will convert some mass into energy and they will release that energy. Once they release that energy, they will become stable. Okay, ma? So the mass of nucleus is always less than mass of individual particles. Okay, that defect in mass, that reduction in mass is nothing but mass defect. Is it clear, ma? Come on, make a note up to here. Okay, here we have taken the example of a deuteron. What is meant by deuteron? So isotype of hydrogen. Hydrogen 1,1 is called hydrogen. Hydrogen 1,2 is called as deuteron, and hydrogen 1,3 is called as tritium. Are you able to understand? See, ma. So in hydrogen 1,2, 2 means what? There is one proton and there is one neutron. That's all. So what is the mass of neutron? 1.008665 atomic mass units. And mass of proton is 1.007825 atomic mass units. So if you add the masses individually, this is the mass you will get. Are you able to understand? But if you take the mass of deuteron nucleus, are you able to understand, ma? I am taking the mass of deuteron nucleus, then how much it is? It is 0.014103 atomic mass units. So definitely this value is less than this value, no? Here I have 0.014, here I have 0.16. Okay, so nucleus mass is less than individual masses of the nucleons. So therefore what is the mass defect? So this value minus this value, so this is the value which I got. Okay, so therefore what is this mass defect? It means that this much amount of mass has disappeared. Inta massu nucleus form ayye process lo mayamaipoyindi. Are you able to understand? So this is the amount of mass which has disappeared when this nucleus was formed. Are you able to understand? So this mass I can convert into energy also, no, by using which relation? By using Einstein's equation of mass energy equivalence. E is equals to mc square. Delta m is nothing but mass disappeared. Okay, and what is the mass disappeared? This much amount of mass has disappeared. So 0.002387 multiplied by, see, already we studied that one atomic mass unit, if it is converted into energy, it releases 931.5 million electron volts of energy. This already we have studied, no? The last class we studied, no? One atomic mass unit of energy, if it is successfully converted into energy, one AMU of mass, if it is converted into energy, then it releases this much amount of energy. So here also I am writing in AMUs only, no? So just to multiply that value by 931.5, then this is the amount of energy which was released. 2.22 million electron volts of energy is released when this much amount of mass has disappeared. Inta mass mayamaipote anta energy release ayindi. Okay, and this amount of energy released is nothing but nuclear binding energy. Okay, what is meant by nuclear binding energy? Because this released energy is responsible for keeping the nucleons at one place. Energy కొంచెం వెళ్ళిపోయింది కదా, all the nucleons they will become stable. Some energy is released, no, so nucleons automatically they will become stable. So therefore this energy is called as binding energy per nuclear binding energy. Okay, so therefore what is meant by nuclear binding energy? Nuclear binding energy definition, how I can write is, I can write like this. Clear, ma? So two definitions I will write. The energy released by which nucleons have combined to form a nucleus. This energy is called as nuclear binding energy. Okay, ma? The amount of energy released which is responsible for making these nucleons to be present at one place. Because energy eldipoyindi kada, now they have to become stable. Clear now? Or one more definition I can write is that, so if this amount of energy is given, clear now? Then nucleons can be separated. By infinite distance. Are you able to understand? What is the meaning of this one? Previously energy released was 2.22, no? Same energy if I give to the nucleus of this neutron, then what happens? Previously this much amount of energy was released. Now same energy if I give again to the nucleus of neutron, then what will happen? Again they will get separated. Okay? Previously all the nucleons, they were in separated states. No? Now if I give this much amount of energy, again the nucleons have the ability to get separated. Are you able to understand? So that is why this energy is also called as nuclear binding energy. Okay, ma? Same for nuclear binding energy, I can write two definitions. Are you able to understand? That is binding energy per nucleon. Okay, ma? So what is meant by binding energy per nucleon? It is called BEN, ma. BE per N, or just you can call it as BEN, binding energy per nucleon. Okay, so BEN means what? Total binding energy divided by number of nucleons. Okay, that is called as binding energy per nucleon. For example, in deuterium, what is the binding energy I got? 2 point. Are you able to understand? This is the total binding energy for this total nucleus, no? Okay, so therefore total binding energy was 2.22 million electron volts divided by how many nucleons are there inside helium? Helium lopala nucleons annu untayi 4, 2 protons and 2 neutrons. So divide them by 4. So here whatever answer you will get, that is called as BEN, binding energy per nucleon. Are you able to understand? Ante okokka nucleon ki enta binding energy release ayindi ani artham. For each nucleon, what is the amount of energy released? That is called as BEN, binding energy per nucleon. Are you able to understand? So 1.1 by 2, 1.1 by 2 is how much? 0.55. That's all, no? So therefore I can write it as a 0.55 million electron volts. Understood, no? So like this we have to calculate binding energy per nucleon. Now here, what is the importance of this binding energy per nucleon? That we will write down. This is the most important point in this topic. Okay, ma? So, importance of BEN. Okay. So first of all, we will study fission, nuclear fission. Okay, ma? What is meant by nuclear fission? If two atoms of lower BEN combine to become one atom of higher BEN, okay, ma? Then energy will be released. Okay, and this process is called as nuclear fission. I said this is fusion, nuclear fusion. Okay, so in nuclear fusion process, in which condition energy will be released, ma? See here, if two atoms of lower BEN, two atoms, their binding energy per nucleon should be lesser. So such atoms, they should combine to become an atom of higher BEN. So rendu lower BEN unna atoms combine ayi edi create avvali, higher BEN atom should be created. Higher binding energy means what? More energy is released, no? So automatically energy will be released. Are you able to understand? So this is the process of nuclear fusion. So which atoms should combine to become what? Lower BEN atoms should combine to become higher BEN atom. Then energy will be released. Understood now? Then we write nuclear fission. nuclear fission. Okay, ma? What is nuclear fission? Single atom of lower BEN, binding energy per nucleon, should split into two daughter nuclei of higher BEN, then also energy is released. Are you able to understand? So this process is called as nuclear fission. Okay. So in nuclear fission, what is happening, ma? So there is one single atom whose BEN value is lesser. So that should be split into two daughter nuclei, and each daughter nuclei BEN value should be greater. So if BEN is greater, it means more energy is converting into mass, no? So automatically energy will be released. So whether it is nuclear fusion or whether it is nuclear fission. Fusion means combination. Fission means getting separated. Are you able to understand, ma? Whether it is a fusion or fission, which atom should convert into which atom? Lower BEN should convert into higher BEN. Then always energy will be released. Are you able to understand, ma? So direct questions will be asked on this topic. Okay. So first of all, let us draw the diagram of different BENs of the periodic table, ma? Come on, make a note of 2 here. Energy should be absorbed in that condition. Are you able to understand, ma? If a higher BEN should convert into lower BEN, then energy should be absorbed. Energy is released only when lower BEN converts into higher BEN. Understood, ma? That's it. So let us make a note of that point also. So what is the note point I have to write? Note point is that, okay, ma? Energy is always released. See, ma, nuclear fission and nuclear fusion reactions, they are very powerful reactions. No, these are the reactions happening in the sun. So sun is releasing very huge amount of energy. How it is releasing? Because it always converts to lower BEN atoms into higher BEN atoms. That is the process which is happening in the sun. Are you able to understand? So energy is always released, okay, when lower binding energy per nucleon atoms convert into higher BEN. So this is the most important point in this BEN concept. Understood, Nama? So Sima, this is the binding energy curve. We have represent all the important elements here. Okay, now see. So on the x-axis we are taking atomic mass, or you can say mass number. Okay, on x-axis mass number 20, 50, 75, 100 like this. Okay, and on y-axis we are taking binding energy per nucleon. BEN I am taking, and BEN I am taking in million electron volts or mega electron volts. Clear? Now see. So hydrogen mass number 2. This is having the lowest BEN. Hydrogen is having lowest BEN. Then followed by tritium. This is a deuteron. This is tritium. Then here I have lithium, helium, then nitrogen, carbon, oxygen 18, oxygen 16, sulfur 32, iron 56, molybdenum 100. Like this I have. Are you able to understand? See, out of all these elements, which is having highest BEN? Iron. Highest BEN is existing for iron, nearly some 8.8 million electron volts. Okay. Highest BEN means what? Highest BEN ante meeku em arthamavutundi? What do you understand? It means more energy has been released, no? Binding energy is greater means that more mass has converted into energy. So it means most of the energy has released. Ekku energy release ayindane kada. Okay. So therefore if most of the energy is released, that particular element will become most stable. Okay. అంటే మీ కాడ డబ్బు లేకపోగా అప్పుల పాలైనారు అనమాట మీరు. అర్థమవుతుంది కదా? మర్యాదగా ఇంట్లో కూర్చొని ఉంటారని అర్థం. Are you able to understand, Amma? So if binding energy per nucleon, if it is greater, it means it has lost more energy. It means more mass has converted into energy. Are you able to understand, Amma? So therefore the element which has highest BEN, it will be always more stable. So of all these elements, iron is the most stable element. So అందుకే ఐరన్ అంత అద్భుతంగా ఉంటుంది అనమాట. ఇట్స్ ఇస్ మోస్ట్ స్టేబుల్ బికాస్ ఇట్స్ BEN వాల్యూ ఈజ్ లార్జెస్ట్. Similarly, elements with atomic number less than 30 and greater than 170, they are unstable. Are you able to understand? Because their BEN values are lesser, less than 8. See, most of the atoms starting from 32 up to approximately 170. Okay, this is here we have 32 no? And here we have 170. All of them, they are above 8. They are above 8 no? BEN 8 paina unnai. Elements from starting from here to here. And these elements in between 32 and 170, they are having BEN of 8 and they are most stable. Okay. So elements with atomic number less than 30 and greater than 170, they are not so stable. Are you able to understand? This is second point which we have to observe. And one more point is that, see here I have hydrogen. Okay. When two hydrogen combine to become helium, this is the process which is happening on the surface of sun. సూర్యుడిలో జరుగుతున్న ప్రాసెస్. ఓకేమా? when two hydrogen, when they combine to become helium. Okay, so hydrogen is having lowest BEN. Hydrogen BEN is very less, but you see the BEN of helium, it is very large. Okay, so lower BEN, when it converts into higher BEN, energy will be released or absorbed? Energy will be released. So therefore, when two hydrogen, when they combine to become helium, very huge amount of energy will be released. Are you able to understand? Similarly, and this process is called what? Nuclear fusion reaction. Two hydrogens, they are getting fused and helium is formed. Okay, lower BN converts into higher BN. Similarly, if you see here uranium 92, okay ma, it can be split into barium and krypton. Okay ma, barium mass number is how much? Barium atomic number is how much ma? It is 56 and krypton it is 36. Okay, now see, so uranium atomic number is 92, but mass number is how much? 238. Are you able to understand ma? When they convert into barium and krypton, this is which kind of process? This is fission process. Are you able to understand ma? And uranium has lower BEN, barium and krypton they have higher BEN. Are you able to understand ma? So when this converts into higher BEN, here also energy will be released. Are you able to understand ma? So those are the note points here which I have written. Element with highest BN is most stable, so iron is the most stable. Okay ma? Except with the lighter nuclei. Lighter nuclei means what? A value less than 30, mass number if they are less than 30, then average binding energy per nucleon is about 8 million electron volts. Okay, it means the elements in between mass number 30 and 170, they have an average BN of 8. Okay, so nuclei with A is equal to 60 have highest BN and they are most stable. It means the elements which are present in this region, they are the highest highest BN is present, so they are most stable. Okay, whose mass number is around 60. So BN is less for both A is equal to A is less than 30 and A greater than 170. So these are the points which you should remember. Okay ma? So whatever it may be, what is the condition here we have to study? If elements of lower BEN converts into elements of higher BEN, then energy is always released. That is the point which you should remember. Okay, that's it. Make a note of. Okay ma? So this is the given question. So find the mass defect, binding energy and binding energy per nucleon for helium nucleus. Okay ma? So mass of helium nucleus is given, mass of proton is also given, mass of neutron is also given. Okay, so first of all, can you say how can I calculate mass defect ma? Mass defect, how can I calculate? Mass defect. Mass defect means what? The amount of reduced energy, reduced mass. Clear nama? So how can I calculate? So mass of individual nucleons, okay ma, minus mass of helium nucleus. This is how I can calculate nama? Mass of individual nucleons minus mass of helium nucleus. Because mass of individual nucleons is always greater when compared to mass of the nucleus. So that the difference of mass is nothing but mass defect, the mass which has converted into energy. Understood me? So therefore, what is the mass of individual nucleons ma? So helium nucleus he gave no? In helium nucleus, how many protons will be there and how many neutrons will be there? Chapandi, 2 protons and 2 neutrons. So therefore, 2 into mass of proton plus 2 into mass of neutron minus mass of helium nucleus. This is what I have to do, no? So 2 times mass of proton is how much? Mass of proton is already given. How much, ma? 2 into 1.007277 plus 2 into mass of neutron. Mass of neutron is how much? 1.008666. Minus of mass of helium nucleus. Mass of helium nucleus is already given. How much? 4.001509. Okay, ma? So if you do this calculation, first of all, I will get the mass defect. Understood, no? And I will write the mass defect, ma? So mass defect which he gave is 0.030377 atomic mass units. So this is the amount of mass which has disappeared when this helium nucleus was formed by combining 2 protons and 2 neutrons. Notes item paina unnara vinta unnara emanna vinali. Okay, this is the mass defect. So then what he is asking, binding energy. Second one which he is asking is binding energy. Okay, now can you say how can I calculate binding energy, ma? Binding energy, how can I calculate? Anybody? Come on, mass defect I have calculated, the amount of mass which has disappeared. Now how can I calculate binding energy? Binding energy you can calculate by 2 methods. Either you can calculate by E is equal to mc square, okay, ma? Or already we have studied that if 1 AMU is converted into energy, it will release 931.5 million electron volts of energy. Already we have studied, no? If 1 AMU, if I can convert into energy, then how much energy will be released? This much amount of energy will be released. Now here also I got answer in terms of AMU only, no? Okay, so therefore substitute. So therefore, energy released, or you can call it as binding energy. Okay, ma? So binding energy is how much? How many AMUs have disappeared, ma? 0.030377 AMU has disappeared. And 1 AMU, if it is converted into energy, this much amount of energy will be released, no? So energy multiplied by mass multiplied by 931.5. Okay, so if you do this calculation, I will get binding energy. Okay, ma? And the answer which I gave is 28.3 million electron volts of binding energy is released. Are you able to understand? Okay, then what is the third question he is asking? Third question is BEN. What is meant by BEN? Binding energy per nucleon. Clear, na, ma? So BEN is nothing but binding energy divided by number of nucleons. So binding energy is how much? 28.3 million electron volts divided by how many nucleons are there in helium nucleus? 4 nucleons are present. So just to do this calculation, I will get the binding energy per each nucleon. Okay, ma? And the answer is 7.07 million electron volts. Okay, this is how we have to do the calculations. Okay, very easy. So here there is a graph given, ma, graph between mass number and binding energy per nucleon. Clear, no, ma? On the x-axis, on x-axis mass number is given, and on the y-axis binding energy per nucleon is given. Okay, then in which of the following processes energy will be released? That is when y converts into 2z, w converts into x plus z, w converts into 2y, x converts into y plus z. In which of these processes energy will be released? Okay, now do you remember, ma? I said energy will be released in which process? Energy will be released in which process? Energy release అవ్వాలంటే ఏం జరగాలి చెప్పండి? So I already said, you know, ma, so when atoms of lower BEN, when they convert into atoms of higher BEN, okay, then energy will be released. Already I said, you know, then energy will be released. Gurtunda idi? Clear, ma? When atoms of lower BEN, when they converts into atoms of higher BEN, then energy will be released. Because higher BEN means what? Binding energy is greater. Binding energy is greater means more energy is released. Are you able to understand now what is meant by binding energy? The mass has converted into energy and that energy is released. Okay, so if BEN is greater, atom is more stable. Already we discussed all these points, no? So when lower BEN converts into higher BEN, then energy will be released. Okay, or you can say that, clear, this is one case, or you can say that if total binding energy, okay, ma, of products is greater, okay, ma, then also energy is released. Okay, so when compared to reactants, if products binding energy is greater, it means more energy is released, and if more energy is released, atoms will be more stable. Understood, no? Now first you take the first reaction, first operation, ma, y converts into 2z. So I will do this calculation, remaining 3 calculations you are supposed to do. Okay, now see, listen very carefully. Y converts to 2Z. Now see where Y is present, this is Y, whose mass number is 60. And what is its binding energy? 8.5. Okay, ma? Therefore, total binding energy of Y is how much? BEN of Y is 8.5. What is the binding energy per nucleon of Y? 8.5. Then what is the total binding energy? That's all, 60 into 8.5. Mass number is nothing but number of nucleons, no? What is meant by mass number? Number of protons plus number of neutrons is nothing but mass number. Ante the mass number ante. So therefore, how many nucleons are there in Y? 60 nucleons are there. And what is the BEN for each nucleon? 8.5. Therefore, total binding energy is nothing but 60 multiplied by 8.5. So this is the binding energy of Y, which is converted into 2Z. Okay. Now calculate for Z. So total binding energy of Z. What is the atomic number of Z? Sorry, mass number of Z? 30. Clear, no? 30. And what is the BEN of Z? 5. So 30 into 5 is how much, ma? 150. Are you able to understand? 150 million electron volts. Now you compare these two. 60 into 8.5 is bigger or 150 is bigger? 60 into 1.5. Do the calculation. 8.5 into or 85 into 6. So 8 6 are how much, ma? 48. 480, 5 6 are 30. So how much it is? 510 million electron volts. Clear? So therefore this value is 510 million electron volts. Okay. So binding energy of reactants is greater or binding energy of products is greater? Binding energy of reactants is greater, no? It means that higher BEN atom has converted into lower BEN. So energy will be released or absorbed? Energy will be absorbed. Energy will not be released. Okay. So therefore in this condition I can say that energy of reactants, reactant you cannot say, just you can call it as mother atom, is greater than energy of binding energy of daughter atoms. Okay, ma? So energy is not released. Which one, ma? 2Z is given. Very good. 2Z is given. No? We have done only for 1Z. So therefore, for single Z it is 150. For 2Z it is how much? 150 into 2. So it is 300 million electron volts. Are you able to understand, ma? Even then also it is 510 and 300. So 510 is greater than 300. So energy is not released in this process, but energy should be absorbed in this process. Okay. Similarly, can you do 2, 3 and 4? Okay, ma? Do the calculation. So in which condition it is released? Okay, ma? So third one I have done. W tends to, W gives rise to 2Y. So W atom, it is converted into 2Y atoms. Okay, ma? So in this condition I see that binding energy of daughter atoms is greater than mother atom. So definitely here in this condition energy will be released. Understood, ma? Similarly, you do the remaining two calculations and see whether energy is released or absorbed. Second one is also energy is absorbed, correct? Fourth one also energy will be absorbed only. Only in third process energy is released. Okay, check it. Okay, so the next concept which we are discussing is about radioactivity. And in radioactivity, first of all, we have to discuss about nuclear stability. So nucleus will be stable depending on two factors. What are the two factors? First one is, so binding energy per nucleon. Okay. So if binding energy per nucleon, if it is maximum, then nucleus will be stable. Already we have discussed this one. For example, if you take binding energy per nucleon of iron, okay, then it is nearly 8.8 million electron volts. So this is the binding energy of iron. It means that the binding energy of iron, this is the maximum out of all the 118 elements we have. So therefore iron is considered to be the most stable element. So therefore if BEN is maximum, definitely nucleus will be stable. And the second fact is neutron proton ratio. Okay, ma? Neutron proton ratio. Okay. So if or I will say so in elements whose Z value is less than 20 or less than or equal to 20, clear, ma? So number of protons will be equal to number of neutrons. Okay. So for elements whose atomic number is less than 20, clear? So the number of protons and number of neutrons, they are almost same. So but for elements whose Z value is greater than 20, clear, ma? So number of neutrons will be greater than number of protons. Okay. So neutron number will become very large when compared to number of protons. Okay. So this is again to obtain stability of the nucleus. So how the increase of neutrons is accountable for increasing the number of protons, let us see. Okay, ma? So if number of neutrons increases, if number of neutrons increase, okay, ma? They come in between protons, and thus the force of repulsion is reduced. Okay, so if a force of repulsion reduces, automatically nucleus will become stable. So nucleus tends to be unstable only because of repulsion between the protons only, no? So therefore these neutrons, what they will do, they will come in between the proton. This is a neutron, so this is a proton, and this is another proton. So as the distance between the protons increases, automatically the force of repulsion between them also reduces. So this is one factor. Okay, for elements whose Z is greater than 82, it means a plumbum, elements with the atomic number greater than 82, that is after lead. So even the number of protons are very large, then the number of protons are also very large. So Z number 82 means what? 82 protons are there. It means even the number of neutrons are very large, so nucleus cannot be stable. Clear, number? So therefore we write for Z greater than 82, even the number of neutrons are very large, okay, but still the nucleus will become unstable. Okay, no? So therefore this results in an activity called as radioactivity. So therefore the elements above atomic number 82, that is after plumbum, so even the number of neutrons are very large, but still they are unstable. So these nucleus, they will try to become stable by emitting alpha, beta and gamma radiations. Are you able to understand, ma? So that concept is nothing but radioactivity. So let us. So therefore what is meant by radioactivity? Okay, ma? So radioactivity, how can I define? Okay, so elements after plumbum, lead 82, okay, ma, try to become stable by emitting alpha, beta and gamma particles. Okay, ma? So this continues until they attain a stable configuration. And what is the stable configuration? Definitely plumbum 82 is the stable configuration. Okay, ma? So any radioactive element, why it is emitting alpha, beta and gamma radiations? It is emitting these radiations only to become stable. That's it. Okay. So therefore, for example, if you take uranium 92-238, what is the meaning of uranium 92-238? Ma? It means 92 protons are present, and 238 minus 92 neutrons are present. Okay. So neutrons are very large when compared to protons, but still uranium is not stable, and it tries to become stable by emitting alpha, beta and gamma radiations. Okay, ma? Now let us have a small discussion on what is this alpha, beta and gamma particles they are made up of. Okay, so what is meant by alpha particle? Alpha particle means it is helium nucleus. So nucleus of helium is nothing but alpha. We know that atomic number of helium is 2 number. It means there are 2 electrons revolving around the nucleus of alpha particle. So if I remove those 2 electrons here, if both the electrons are removed, then what I am left with? I am left with only helium nucleus. So that helium nucleus itself is called as alpha particle. So therefore alpha particle can be written as helium 2-4. We know its atomic number is 2, it means number of protons will be 2. And what is the mass number? Mass number is 4, because there are 2 protons and there are 2 neutrons. Clear, no? And because we have removed 2 electrons from this one, only protons are present. So therefore the charge of helium nucleus will be 2 plus. Okay, therefore it is a positively charged particle. Okay, ma? So what kind of particle is this? This is a positively charged particle. Alpha particle is a positively charged particle. Clear, no? So therefore, if it is a charged particle, then definitely it means that it will be deflected by electric field also, it will be deflected by magnetic field also. We know that the charged particles, they will be deflected by electric field as well as magnetic field also. Okay, that we will discuss later. Okay, then if I study about a beta particle, okay, ma? And one more property of alpha particle is, if alpha particle is emitted, clear, ma? Then proton number reduces by 2 reduces by 2 units and mass number reduces by 4 units. Okay, ma? So this is one point which you should remember. So from the nucleus, if an alpha particle is ejected, it means alpha particle is made up of 2 protons and 2 neutrons. So definitely proton number reduces by 2. So what is meant by proton number reduces by 2? It means atomic number of that element also reduces. It means if all the chemical properties that depends on atomic number only, no? It means that if alpha particle is emitted, so this radioactive element, it converts into another radioactive element because proton number is reduced here. Are you able to understand? So therefore proton number reduces by 2 units, and because it has 2 protons and 2 neutrons, mass number also reduces by 4 units. Clear, no? Then we study about beta particle. Okay, what is beta particle? It is just like an electron. Okay, ma? Beta particle is just like an electron itself. But the point is that this electron, it is not the electron which is revolving around the nucleus. No. Okay, ma? This electron would have been formed inside the nucleus. It is not that electron which is revolving around the nucleus. So therefore what we write, therefore it is produced inside the nucleus. Okay, but it has same properties of that of electron. So its mass is also same as that of electron. Clear? Its charge is also same as that of electron. Okay, now this beta particle, definitely it is a charged particle. It is a negatively charged particle. So this particle also will be deflected by both magnetic fields as well as electric fields. Okay, ma? And how this beta particle is created? Neutron, it gets split into proton plus beta particle. So this is what is happening actually. Okay, ma? So inside the what you call beta particle, neutron, it converts into a proton and it converts into a beta particle. Clear, ma? So therefore neutron is converting into proton. So mass number does not change because the mass of neutron and proton is almost the same. Okay, so there is no change in mass number. But one neutral particle, it has converted into a charged particle. Okay, so definitely if number of proton is increasing, it means if one beta particle is emitted, Z value increases by 1. Okay, ma? So what is meant by Z value? Atomic number increases by 1 here. So that is the property of beta emission. So therefore write down. Okay, therefore what we write? Okay, ma? Therefore we write, if beta particle is emitted, then what happens? Mass number does not change. Mass number does not change. There is no change in mass number. Okay, ma? But proton number increases by 1. Okay, ma? 1 unit. 1 means 1 unit. Proton number increases by 1 unit. Okay. Then what about the emission of gamma particle? Let us see. Okay, gamma particle. So gamma particle is nothing but it is a photon. It is a packet of electromagnetic energy. Are you able to understand, ma? See, whenever alpha and beta particles, when they are emitted, nucleus may be in excited state. Nucleus may be present in excited state. So again, to come to ground state, so this alpha and beta particle, after the emission of alpha and beta particle, to return to ground state, nucleus may emit an photon. That photon is nothing but a gamma particle. Are you able to understand? So therefore, when alpha or beta is emitted, okay, ma? Then nucleus may be in excited state. Okay, so when it is in excited state, it tries to come to ground state by emitting what? By emitting a photon, or you can call it as a gamma particle. Okay, so because this is a photon, this is an uncharged particle. Okay, ma? It doesn't have any kind of charge. Positive charge is not there, negative charge also is not present. Because it is not a charged particle, it is not deflected by magnetic field, it is not deflected by electric field also. And when gamma particle is emitted, there is no change in mass number, there is no change in proton number also. Clear, nama? So make a note of that point. What is the note point I have to write? So there is no change either in mass number or atomic number. Okay, ma? And remaining properties of this alpha, beta and gamma particles we will draw in the next slide. Okay, ma? Let's study about the properties of alpha, beta and gamma particles, ma? Okay, so see. So first property, identity. What is meant by identity? These particles, they are made up of what? That is called as identity. Clear, no? So alpha particles, already we studied, they are helium nuclei, no? When you remove 2 electrons from the helium atom, then you have only nucleus, no? That nucleus itself is called as alpha particle. Clear? So therefore it is a helium 2 and 4. atomic number is 2, mass number is 4. That is an alpha particle. Clear now? And beta particle, they are electrons. Beta particles, they are nothing but electrons. But these are not the electrons that were revolving. So around the nucleus, electrons will be revolving. Electrons kadi. These are the electrons which are created inside the nucleus. Nucleus local form of. But they are just like electrons only. Mass is also same, charge is also same. But they are not the electrons which are revolving around the nucleus. Nucleus chuttu tirugutu untayi avi kadi. So they are formed inside the nucleus. Nucleus local form of. Clear now? So therefore here you can write not revolving electrons. They are not the electrons which are revolving. Okay. And beta particle. What is meant by beta particle? It is radiation energy, light energy, or you can call it as energy like X-rays. Are you able to understand now? So we know radiation. No? So gamma particles is not matter. It is just radiation. So this is the contents of this alpha, beta, and gamma particles. Charge. So what is the charge of alpha particle? See, from a helium atom, if you remove 2 electrons, then what will be the charge of helium? 2 plus. No? If you remove 1 electron, charge will be 1 plus. If you remove 2 electrons, charge will be 2 plus. So therefore charge of helium will be 2 times the charge of electron. Electron charge is negative, 1 negative. But charge of alpha particles is 2 positive. So I can write He 2 plus. So this is the charge of alpha particle. Clear now? And beta particle, it is just like electron, already we said no. So therefore its charge will be equal to the charge of electron itself. Okay. And gamma particle. Gamma particle is just a radiation source of radiation energy. So therefore this does not have any charge. So out of alpha, beta and gamma, alpha and beta they are charged particles and they are matter. But gamma particle, it is not a particle, it is radiation. Or you can say they are made up of particles called photons. Understood no? Okay. Similarly, penetration range. So how deeply they can penetrate into matter, that is called as penetration capacity. Okay, see ma'am. Alpha particle is a very heavy particle. No? Alpha particle is a very, very heavy particle. So therefore, it cannot penetrate into matter. Matter lo kadi penetrate to avaledu. For example, if I incident alpha particle on paper, it cannot pass into paper also. Paper lo kuda vedaladu. It's one alpha particle. Clear no? And in air, it can enter into air only up to a distance of 5 centimeters of it. Air lopala aithe just oka 5 centimeters width. So therefore, penetration capacity of alpha particle is very less. Clear no? Whereas if you see the penetration capacity of beta particle, beta means electron, no? Very small. So it has good penetration capacity. It can enter into 1 or 2 papers also. And in air also it can travel up to 500 centimeters. Are you able to understand now? If you release an alpha particle into air, beta particle, it can travel up to 500 centimeters through air. Okay? And when it is incident through matter, matter means paper or like that, then it can enter 10 millimeter. 10 millimeter means 1 centimeter of matter it can enter, which one beta particle. Then what about gamma particle? This is radiation, no? This is radiation, X-rays. Okay? So therefore its penetration capacity will be very large. So it can travel through several centimeters also in lead metal. If you take lead metal, it can enter into several centimeters of lead metal also. Okay. Next, fluorescence. What is meant by fluorescence? If any particle goes and strikes any fluorescent surface, it will give a bright colored spot. No? That bright colored spot is called as fluorescence. Are you able to understand? So in gold foil experiment, Rutherford, what he has done is he has taken a zinc sulfide screen, and on that zinc sulfide screen, if this alpha particles go and strike, then a bright spot will be created temporarily. That property is called as fluorescence. Clear number? So now let us see the fluorescence of alpha, beta and gamma. Can cause fluorescence only on some substances. So when alpha particles strike some substances like zinc sulfide, then it can create a bright spot. Okay, ma? And gamma, beta particles, definitely they can cause fluorescence, and gamma particles fluorescence is very, very, very less. Okay, that's it. Ionizing power. What is meant by ionizing power, ma? Ionizing power means SIMA. So the ability to dislocate electrons from another atom is called as ionizing capacity. For example, if alpha particles are released into the atmosphere, they are very heavy particles, and size of alpha particle is also very large. So when it comes into contact with another atom, for example like oxygen or nitrogen in air, then easily it can dislocate the electrons which are present in either oxygen or nitrogen. Okay, ma? అందులో electrons ని బయటికి తీసేస్తుంది because it is a very heavy particle. Okay, ma? Very easily it can remove electrons from other atoms. That property is called what? That property is called as ionizing power, and it is a very large particle, and comparatively it travels so slowly also. So whatever atoms it find in its path, it will dislocate electrons from that atom. Where atoms నుంచి electrons ని బయటికి తీస్తుంది. Clear ma? That property is called as ionizing power, and ionizing power of alpha is very large. This is the largest. Penetration power is the least, whereas ionizing power is the highest. And when compared to alpha, what is the ionizing power of beta? Beta is just electron. So therefore its ionizing capacity will be very less because its energy also is very less. Okay, ma? So how much it is? 1/100 the times of alpha particle. 1 though and very less. And when compared to gamma, and gamma is still 1 by 100 times less than beta. It means 1 by 10,000 times less than alpha particle. Are you able to understand? Ionizing power of gamma particle, it is 1 by 100 times less than beta. Beta is already 1 by 100 times less than alpha, no? So what is the ionizing power of gamma? 1 by 100 into 1 by 100? 1 by 10,000 times lesser when compared to alpha particle. So like this also questions can be asked. Next, speed. Less than speed of light, less than speed of light. But this is radiation, no? It exactly travels with the speed of light. Radiation. Every radiation in vacuum, it travels with the speed of light, whether it is alpha, beta, gamma, X-rays, UV rays, visible spectrum, whatever it may be, every radiation has so much speed, 3 into 10 power 8 meter per second. Clear now? Next, effect of electric and magnetic fields. So in the path of alpha, beta and gamma rays, if you place electric field and magnetic field, then what will happen? See, every charged particle will deviate when electric fields and magnetic fields when they are placed. Are you able to understand? And out of alpha, beta and gamma, which are the charged particles? Alpha and beta, they are charged. Which is a neutral particle? Radiation, gamma. It is not charged, no? So gamma particle doesn't deviate, whereas alpha and beta, they will deviate from their path. That's all together. Okay. So deflected by both fields. This is also deflected by both fields, but here you cannot find any deflection. Okay. Next, mass. Mass is exactly equal to mass of helium nucleus, because alpha particle is nothing but helium nucleus, and this is exactly electron, so mass of electron, and it doesn't have any rest mass. Photon does not have any rest mass. Photon cannot be in rest position, first of all. Radiation is made up of photon, according to Planck's quantum theory. Total radiation is made up of photons, and photons cannot be in rest position. Okay, so zero rest mass. But when they are in movement, they have momentum. No? When photons are movement, when light energy is moving, it has momentum, and when it has momentum, it has mass. అర్థమవుతుంది కదా? మూమెంట్లో ఉన్నప్పుడు గామా పార్టికల్కి మాస్ ఉంటుంది, రెస్ట్లో ఉండదు కాబట్టి మాసే ఉంటుంది. క్లియర్? దట్స్ ఇట్. సో నెక్స్ట్, ఎనర్జీ. సో ఎనర్జీ is approximately equal to 6 billion electron volts for alpha, approximately 1 million electron for beta, and it is 0.01 million electron for gamma. So which is the least energetic particle? Gamma is the least energetic particle, and highest energetic particle is alpha particle. Physics. So most of the questions may be theoretical bits also, rather than problems. Okay, theory bits also there is a good chance of getting asked in modern physics. So listen to the concept very carefully. So Sima, rules of radioactive decay. So what are the rules followed by radioactivity for giving this alpha, beta and gamma particles? Clear now? So Rutherford and his associates, they gave some laws. They gave some rules of what is the process in which this radioactivity will take place. Clear? So first one which they said is unaffected by temperature, pressure, okay ma, or external factors. Okay ma? It is not at all affected by, already we discussed this point, so whatever may be the temperature of radioactive substances and how much pressure you put on them, and if you apply any external force, they are not affected by all of them. So when they release alpha, when they release beta, when they release gamma, nobody knows. Are you able to understand ma? So భయంకరమైన మూడు మనుషులు అన్నమాట, ఎప్పుడు ఎలా బిహేవ్ చేస్తారో దానికి తెలియదు. So that is the first property. Second one is, okay ma, so either alpha or beta only is released. Okay ma? So what is meant by either alpha or only beta is released? It means when alpha is released, beta is not released, and when beta is released, alpha is not released. Either alpha or beta. And gamma is a different condition. Gamma is the only radiation number. So when either alpha or beta, when they are released, and when the nucleus, when it is in excited state, then it comes to normal state by giving gamma radiation. Are you able to understand? ఈ రెండు ఎమిట్ చేసినప్పుడు ఆవేశంలో ఉంటుంది అన్నమాట, in excited state. So to reduce that excited state, it will give some more energy in the form of radiation. Okay, and 2 alphas or 2 betas are also not released. Okay, 2 alphas are also, they are not released. Similarly, 2 betas also, they are never released. Are you able to understand? So alpha and alpha, after an alpha particle is released, again one more alpha cannot be released. Similarly, 2 alphas at same time also cannot be released. Are you able to understand? This is another property. Okay, so third property is when alpha particle is released, okay ma, then what happens is atomic number reduces by 2 and mass number reduces by 4. Okay ma? Because helium nucleus, it will have mass number 4, no? What is the mass of helium? 4 atomic mass units. And what will be its proton number? 2 protons will be there. So when an alpha particle is released, mass number reduces by 4, atomic number reduces by 2. Okay, if I take one example, uranium 92-238, okay ma, it converts into thorium 90-234 by emitting one alpha particle. So this is what will happen. Understood now? So element is completely changing. Uranium has converted into thorium. Atomic number of uranium 92, thorium 90, mass number 238, but mass number of thorium is 234. So mass number reduced by 4, atomic number reduced by 2. So that is what will happen. Okay, ma? Fourth one is when beta particle is released, okay, then atomic number increases by 1. Atomic number increases by 1 and mass number does not change. Mass number does not change. Okay. For example, carbon 614, it converts into nitrogen 714 plus 1 beta particle. So this is what will happen. Okay, but carbon 614 it is a radioactive isotope. Carbon 614, it is not so stable. It is very unstable. Okay, but so it tries to attain stability by emitting 1 beta particle. Okay. So atomic number 6, but atomic number of nitrogen 7. Clear now? So atomic number increased, no? Clear? But what about mass number? Mass number is not changing. What is the reason for this one? Here we will write. The reason is that neutron, it gets split into proton plus beta particle. This is what will happen. So out of many neutrons, one neutron, it splits into what? Neutron will split into proton and a beta particle. This is a positively charged particle and this is a negatively charged particle. Positive and negative, they will become neutral, no? So therefore neutron is a neutral particle. It splits into proton as well as a beta particle. Okay, ma? So neutron atomic mass units is 1, no? Mass of neutron is 1 AMU approximately. 1.0083 something will be there, but approximately equal to 1 AMU. And mass of proton is also approximately 1 AMU, 1.0078, almost equal to 1 AMU. So mass number is not changing because 1 AMU is converted into 1 AMU. Mass number never changes. Okay, ma? But definitely one neutron has disappeared and one proton has formed. Adi jarigindi kada? Oka neutron mayమైపోయింది. దాని ప్లేస్లో ఒక ప్రోటాన్ వచ్చింది. But whatever it may be, mass number it is not change. Mass number is number of protons and number of neutrons. Mass number lo marpu ledhu kada. Always it is constant. So 14 remains to be 14. Okay. And this extra particle, beta particle, which is released, that is released into the atmosphere. Are you able to understand now? Make a note up to here. Okay, ma? So understood now what is happening? Why mass number is not changing, but proton number is increasing, ma? So one proton has become extra, no? So proton number increases by 1. But mass number is not changing because neutron only it is converting into a proton. So this is what happens in the case of beta particle. Okay. Next, fifth one. When alpha or beta is released, okay, ma? And when nucleus is in excited state, then it comes to ground state. Ground state means normal state, ma? By emitting gamma radiation. Okay, ma? That is in the form of photon. It will release the extra energy and it comes to ground state. Okay. One more point is that, okay, sixth one. So the rate of disintegration is dependent on initial number of atoms not disintegrated or undisintegrated. What is the meaning of this statement, ma? So how many atoms are disintegrating per second? Disintegration means what? Either the emission of alpha or beta is called as disintegration. Are you able to understand, ma? And how many atoms are disintegrating per second? It depends on what? It depends on how many atoms are present which are not decayed, which are undecayed. Are you able to understand? If there are only 100 atoms, very few atoms will disintegrate. If there are 1000 atoms, more atoms will disintegrate. If there are 10,000 atoms, some more atoms will disintegrate. This is understandable, no? Only atoms unte disintegration kuda konchame. If there are more atoms, more disintegrations can happen. Okay. So these are some of the laws which are given by Rutherford and his associates. Understood, no? Make it note. Okay, ma? So see. So next, what we have studied, what was the last statement we have written in Rutherford's laws? We have written that rate of disintegration depends on initial number of undisintegrated atoms. This is what we have studied now. So that statement, we will try to derive some mathematical conclusions of that. Okay, so see. So rate of disintegration depends on initial number of undecayed atoms. If more number of atoms are present which have not released alpha, beta or gamma, then rate of disintegration, rate of emission of alpha, beta and gamma also will be greater. Are you able to understand? So therefore rate of disintegration, how can I write? Rate of disintegration, how can I write mathematical, ma? minus dn divided by dt. I can write like this. Minus means the number of atoms are decreasing. Okay, number of atoms which are undecayed, they are reducing. Okay, because when they start emitting alpha, beta and gamma, more number of atoms are disintegrating. It means the number of atoms left for disintegration, they are reducing continuously. Okay, what is meant by dn? Change in number of atoms which are decaying. dt means change in time. So rate of disintegration minus dn by dt depends on what? It depends on n. That's all. It depends on number of atoms which are undecayed. What is meant by n here? Number of atoms undecayed, which have not decayed still. So if there are more atoms not decayed, then rate of disintegration also will be greater. So what is meant by n here? N means number of atoms left undecayed, which have still not decayed. It has not emitted one alpha also, one beta also, or one gamma also. Okay, then the rate of disintegration is directly proportional to n. So minus dn by dt can be written as lambda into n, where lambda is a constant. To remove proportionality symbol, I have to write a constant, and this lambda is called as a decay constant. Okay, this is called as a decay constant. Okay, and this decay constant, it varies from material to material. Okay, now so therefore I will do some manipulations here. So dn by n is equals to lambda into dt. Okay, so just this n I have taken to this side, dt I have taken to the other side. Then I have dn, so therefore what I will do is I will integrate on both sides. Okay, so when I integrate on both sides, what I will get, so minus I will take to this side, and here I will write a plus. So therefore, so log to the base e of n is equals to minus lambda into t plus n. So this is what I will get, or instead of n I will write k. Okay, so this is the method of integration. See here, differentiation of log n is 1 by n. Differentiation of log x is how much? 1 by x. So integration of 1 by n will become log n, because integration and differentiation, they are opposite processes. Okay, so differentiation of log x 1 by x. Integration of 1 by x dx log x. Okay, and integration of dt will become t. Lambda is a constant. Okay, and when I integrate, there should be some constant values in the initial conditions, and those constant values are written by k here. So these are the rules of integration. Are you able to understand now? So see here, integration of minus lambda into dt. Lambda is a constant, I will take out of integration. So integration of dt, integration and differentiation, they will get cancelled. So minus lambda into t. This is what I will get. But in the initial conditions also may be present. So after every integration, you have to write a constant. Are you able to understand now? So that constant I am taking to be k. Now see. Now let us see how we can further proceed here. See now. So if t is equal to t naught, what is meant by t is equal to t naught? So when I am taking initial time, that is when I started observation, that time is called as initial time, no? And that time I will call it to be 0. Okay, that is when I started observation, from there only time will start, no? So time is 0. So if I take a time 0, then n will become n naught, no? What is meant by n is equal to n naught? The number of atoms which are left for undecayed, that is equal to initial number of atoms left for undecayed when I started observation. Okay, n means what? Number of atoms left undecayed. N naught means that is also number of atoms left undecayed when I started observation. Name observation starts chesinapudu, the number of atoms present were n naught. Understood now? Now substitute all these values here. Therefore I can write log, instead of n I can write n naught, no? Because initial number of atoms is n naught, base to the e. So minus lambda into time is 0, no? Time is 0 plus k. Okay, lambda into 0, 0. Therefore what is k value I got? K value is log to the base e n naught. This is k value. So therefore I can take this k value and substitute here. Okay, so let it be my first equation. So substituting k in 1. Therefore what I will get? I will get log n to the base e is equals to minus lambda into t plus, instead of k what I can write? Log n naught to the base e. This is what I can write. అర్థమవుతుందా ఎలా ప్రొసీడ్ అవుతున్నామో? Okay, these calculations you have to do 1 or 2 times. Then you can understand actually what is happening here. Are you able to understand? Now, so take all log values on one side. So log n to the base e minus log n naught to the base e is equals to minus lambda into t. So log m minus log n, log m by n. That is the rule now. So therefore log to the base e n divided by n naught is equals to minus lambda into t. Okay, so I got relation up to here. Now what I will do? I will apply logarithms on both sides. So applying log on both sides. Then what I will get? Then I will get n divided by n naught is equals to e power minus lambda into t. So this is the relation which I will get. Okay, ma? So applying log rules on both sides. Okay, see my here. n by n naught e power minus lambda t can be converted into of this form also when you apply logarithms. Are you able to understand? These are the rules of logarithms. ఇప్పుడు నేను అవన్నీ ఎక్స్ప్లెయిన్ చేయాలంటే కష్టము. యూ ట్రై టు స్టడీ ఆఫ్టర్వర్డ్స్. ఓకే, సో దిస్ ఈక్వేషన్ కెన్ బి కన్వర్టెడ్ ఇంటూ దిస్ ఈక్వేషన్. So therefore n can be written as n naught e power minus lambda into e. So this is an important relation. Are you able to understand? So what is meant by n here? Number of atoms left undecayed after a time of t. T is interval of time, no? And what is meant by n naught? Before that time, how many atoms were left for undecayed? That is when you started observation. Okay, ma? So for example, if I take these atoms is 100, this atoms is some 60. What is meant by 60 and 100? When you started observation, number of atoms left undecayed were 100. And after a time of t, now how many atoms are there? Only 60 atoms are there. It means so 40 atoms have disintegrated. Either they have released alpha or either they have released beta. That is the meaning of this equation. So n is equals to n naught e power minus lambda into t. Very important equation to calculate the number of atoms which are left undecayed after a time of t. Okay, ma? So therefore what is n here? Number of atoms left undecayed after a time of t. That is called as the equation of rate of disintegration. Understood, Amma, what is happening? Make it out. Then it is very easy. Okay, now see. So we will study next about decay constant. Okay. So already we have studied that radioactive disintegration is directly proportional to number of atoms, Nama. Radioactive disintegration is directly proportional to number of initial atoms which are left undecayed. Okay. So therefore, to remove this proportionality symbol, I have to write a constant, and that constant itself is called as decay constant. So therefore, lambda can be written as minus dn by dt divided by n. This n comes to this side. This is the equation. Now, how can you give a statement for lambda by looking at this statement? By looking at this equation, decay constant ki statement ela rastar cheppandi. What is meant by decay constant? Come on. dn by dt is nothing but the number of disintegrations or rate of disintegration. Rate of disintegration means what? How many atoms are disintegrating per second? dt means per second. Okay, ma? How many atoms are disintegrating per second divided by original number of atoms left undecayed. That is called as lambda value. Okay, ma? If lambda value of a particular radioactive substance is greater, it means what? For example, uranium radioactive substance, carbon 614 radioactive substance, thorium radioactive substance. Are you able to understand? So in all of them, consider the lambda value of one radioactive substance is greater. Then what do you understand? If lambda value is greater, what do you understand? So look at the equation. Total definition, how can you say? For example, I am comparing two radioactive substances now. For one radioactive substance, I have understood that its lambda value is greater. What do you understand? No, what I understand is that for same number of atoms, the disintegrations will be greater. Okay? For example, you take a radioactive substance X, okay, ma? And Y. Two radioactive substances I am taking. Okay? So here I have initially 1000 atoms, here also I have 1000 atoms ready for disintegration. Disintegrate avvadaniki ready ga unnai. So X 1000 atoms, Y also 1000 atoms. You can say this is uranium, this is thorium, anything. Okay, ma? So out of 1000 atoms, 5 atoms are disintegrating per second. For every 1 second, how many atoms are disintegrating? 5 atoms are disintegrating. Okay, ma? But in Y material, only 1 atom is disintegrating per second. Okay, then whose lambda value is greater? Your lambda value account? Definitely X. Why? Because 5 atoms per second is nothing but dn by dt, no? And n value is same, n value is 1000. Number of initial atoms, that is constant. But number of disintegrations per second, if it is greater, therefore we can say its lambda value is also greater. That is meant by lambda. Okay, ma? So for the number of available atoms, how many disintegrations are happening, that ratio is called as lambda. Okay? కొన్ని atoms ఎక్కువ disintegrations జరుగుతున్నాయి అనుకోండి, it means lambda value is greater. Clear? Right on. Okay, ma? So therefore, how can I define lambda? The number of disintegrations to the ratio of available atoms undecayed is called lambda. Is called as decay constant. So you write this example also. Okay, ma? So what is the lambda value of X here? 5 divided by 1000. Clear now? And what is the lambda value of Y here? 1 divided by 1000. 5 disintegrations out of 1000. One disintegration out of 1000. Which one is greater? Definitely lambda x is greater. Understood now? That is called as the rate or the decay constant. Understood now? Okay. And if I want to do some more mathematics, I can do. Okay, no? So see. So we know that n is equals to n naught e power minus lambda into t. This equation already we have derived, no? The equation of radioactive disintegration. N is equals to n naught e power minus lambda into t. Okay. Now I will do one thing. Let us take lambda is equals to 1 by t. Just I will see what will happen. Lambda value, how much I am taking? 1 by t. Time taken. Then substitute there. Then n is equals to n naught e power minus, instead of lambda I will write 1 by t, and t is already present. Okay. So t and t will get cancelled. Then what I will get? N is equal to n naught e power minus 1. This is what I will get. Clear number? So therefore n naught by e is equal to n. So n is equals to n naught divided by e. And what is e value? E value is 2.718 approximately. Okay. So therefore it is how much? 0.37 n naught. So therefore n is equals to 0.37 n naught. So by doing this calculation, what do you understand? What do you understand? చెప్పండి. ఎందెందో చేసుకుని లాస్ట్కి ఎందెందో వచ్చింది. మీకేం అర్థమైంది చెప్పండి. వాట్ హ్యావ్ యూ అండర్స్టాండ్? జయంతి చూస్తాం ఏంది నేను గ్రహాంతరవాసి జీవిలాగా ఉన్నట్టు ఫేస్ పెట్టిన తర్వాత సిమా lambda I have taken reciprocal of time, no? Lambda I have taken to be reciprocal of time. T is nothing but time only, no? After some instant of time. So when I substituted these values, I got this value, n naught by e is n naught divided e value 2.718. It is 0.37 times of n naught. It means that n naught is the number of atoms initially when I started observation number, and n value is 0.37 times of n naught. It means 100 minus 37, how much? 63. 63% of the atoms have disintegrated. What is the meaning of this one? N is equal to 0.37 n naught. It means only 37% of the atoms are still ready for disintegration. It means already how many of them have disintegrated? 63% have already disintegrated. Okay, ma'am? So therefore lambda is defined as that reciprocal of time taken, reciprocal only, reciprocal of time taken for 63% of the atoms to disintegrate, or for 37% of the atoms to be still ready for disintegration. That reciprocal of time is called as lambda. Time taken kaadu, reciprocal of time taken, for which 63% of the atoms should be disintegrated. 100లో ఎన్ని atoms లేచిపోవడం అంటే అది కదా. How many atoms should disintegrate? 63% should disintegrate, and only 37% should be still present. That reciprocal of time taken is nothing but lambda. Understood, number? Make a note. So therefore what I write? Okay. Therefore what I write is lambda is the reciprocal of time taken for 63% of atoms to disintegrate. Okay, or time taken, reciprocal of time taken for what? For 37% of atoms still ready for disintegration. Disintegration and decaying both are same. Are you able to understand? So that amount of time taken is called as lambda. అర్థమవుతుంది కదా? That's it. సరిపోయి. Okay. So yesterday we have studied a decay constant, no? Okay. So the next concept which we are studying is half-life. So what is half-life? Write down. So time taken for half of the atoms to disintegrate. Okay, ma? So this time is called as half-life. Are you able to understand, ma? Time taken for half of the atoms to disintegrate is called as half-life. So what is the meaning of this one? Let us see. See, for example, we have 100 atoms. 100 atoms are present which are undecayed. Undecayed means what? Undecayed means they have not emitted alpha, they have not emitted beta, or they have not emitted gamma also. That is called as undecayed. And next, this 100 atoms, they should convert into 50 decayed atoms plus 50 undecayed atoms. Are you able to understand? So half of the atoms should disintegrate. And what is meant by disintegration? Either emission of alpha or either emission of beta. If alpha is emitted, then also it is called disintegration. If beta is emitted, then also it is called as disintegration. So therefore, 50 atoms should be undecayed and 50 atoms should be already decayed. Then this time taken is called as half-life. Are you able to understand? And half-life varies from material to material. So for some elements, half-life may be some thousands of years also. For example, if you take carbon 614, half-life is nearly some 5,640 years. Are you able to understand? And for some more isotopes, it is only 16 minutes or 17 minutes only. Are you able to understand? So what is meant by half-life? Time taken for 50% of the atoms to disintegrate, and the remaining should be how much? Remaining should be 50%. So that time is called as half-life. Are you able to understand? So mathematically, let us see how we can calculate this one. Already we have written the equation of radioactivity decay yesterday. No? N is equals to N naught e power minus lambda into T. This already we have studied. No? Yesterday we derived this one. What is meant by N here? N means number of atoms which are undecayed. Number of atoms undecayed. Are you able to understand? N naught is equals to initial number of atoms undecayed when we started observation. That is the relation between N and N naught. Okay. Now see. So therefore, after half-life, okay, N will become N naught divided by 2, no? Is it correct? No? After half-life, how many atoms should be there which are ready for disintegration? It is only half of original number of atoms. Ante kada half-life ante. Clear, ma? So after a time of T, how many atoms should be there which are ready for disintegration? N naught divided by 2, where N naught is initial number of atoms. So substitute here. So therefore, instead of N, what I will write? N naught divided by 2. So these many atoms are left. And this is equals to N naught e power minus lambda into capital T 1 by 2. Okay, ma? And for half of the atoms to decay, what is the time taken? Time taken is called as half-life. So that is why instead of small t, I am writing T 1 by 2. Are you able to understand? Now see what are the terms which get cancelled. So N naught and N naught, they will get cancelled. Okay, ma? So therefore I can write 1 by 2 is equals to e power minus lambda into T 1 by 2. This is what I can write. Okay. Now if I want to remove this symbol, I can do one thing. I can write 2 is equals to e power lambda into T power 1 by 2. I can write like this. Are you able to understand? And now if I want to apply logarithms, how I can write is log 2 to the base e is equals to lambda into T power 1 by 2. This is how I can write. This is the method of applying the logarithms. Okay. So you ask your mathematics madam. Further she will explain how to apply the logarithms. Now logarithm methods I cannot explain you. Are you able to understand? So when you apply logarithms, this is what you will get. Okay. So therefore, what is half-life? T half-life is equals to log to the base e divided by lambda. So this is the equation for half-life. Are you able to understand? So half-life means what? Time taken for half of the atoms to disintegrate. If half of the atoms are disintegrated, remaining is half, no? Half of the atoms are left which are undecayed. Okay. So equation is log 2 to the base e, that is natural logarithm of 2 divided by lambda. This is the equation.
2 power log 2 into log e.
Huh?
2 into log e.
2 into, no, I cannot write like this. If it is 2 square, then 2 will come to this side. But here I am taking log of 2, no? So 2 will not go to the other side. Are you able to understand? No? Same equation I can also write T half is equals to 0.693 divided by lambda. Because, what is the reason? Because since log 2 to the base e is nothing but 0.693. Are you able to understand? No? So this is the equation for half-life. So half-life depends on what? Half-life depends on decay constant. Okay, ma? So if decay constant is greater, half-life will be lesser because they are inversely proportional. No? And what is meant by decay constant? Decay constant ante nenu em chadukunnam manamu? Cheppandi. Decay constant means number of disintegrations per second. That is called as number of disintegrations per second and divided by the number of original number of atoms. That's what we have studied. No? Okay, ma? It means if decay constant is greater, so the element will disintegrate more rapidly. So half-life will be lesser. So if decay constant is greater, half-life will be lesser. Decay constant ekku undi ante meaning emi for available number of atoms, more atoms are disintegrating. That is called as decay constant. No? Clear, no? All the definitions you should remember very, very, very carefully. Clear, no? So therefore I can write half-life is inversely proportional to lambda. That is, if lambda increases, half-life decreases. So this is the equation. Okay, ma? And similarly from the same equation you can write a lambda is equals to 0.693 divided by T half. You can write like this also. Understood? No? Make a note. Antavaraku rayandi. Okay, now see, man. So we are discussing some very useful equations to calculate half-life. Okay, so listen carefully. So at t is equal to 0, what is meant by at t is equal to 0? when we started observation. That is the meaning of this one, Amma. When we started observation, the number of atoms which are ready for disintegration or number of atoms which have not disintegrated is equals to n0. So from the starting of the chapter also same numerology we are using, no? So number of atoms at the initial position is n0. So after one half-life, what is meant by half-life? Time taken for half of the atoms to disintegrate. After one half-life, that is when t is equals to t half, okay, ma? How many atoms will be left, ma? Only half of the atoms have disintegrated and half of ready for disintegration. So therefore, n means number of atoms which are ready, and that is equals to initial number of atoms divided by 2 only, no? That is the meaning of this one, no? Half-life tarvata sogam lechipoyinayi sogam unnai annamata. Are you able to understand, ma? So half of the atoms are present, so n0 divided by 2. And n0 divided by 2, I can write n0 into 1 by 2 power 1 also, no? Okay, ma? It means that here I have 1, here also I have 1. Is it clear? Next let us write one more condition. And after second half-life, okay, ma? That is when t is equals to 2t half, okay, ma? One half-life is completed, half of the atoms are remaining, and after one more half-life, then what will happen here, no, ma? Then again I can write, now the number of atoms is n0 into 1 by 2 power 1 divided by 2. That's all, no? Okay, ma? After one more half-life, what will happen? This is the total number of atoms which are ready after one half-life, no? And in that half-life, again half of the atoms will be decayed and half of the atoms will be present. So here we got already half atoms, no? In that again half. For example, let us take n0 is equal to 1000, example. After one half-life, how many atoms are present? 500. After one more half-life, now it should be 250 only, no? It means 500 again I have to divide by 2. So therefore, this equation I can write it as n0 multiplied by 1 by 2 power 1 plus 1 is 2. Okay, this is how I can write. So it means after two half-lives, first half-life, second half-life, how many number of atoms are available, ma? n0 into 1 by 2 power 2, 1 or 1 by 2 whole square. Like this I can write. Clear, no? Now let us go for after third half-life. Okay, ma? Third half-life, that is, what is the time? T is equal to 3 into t power 1 by 2. Okay, ma? 3 times the half-life. Now how many atoms will be there, can you say? N is equals to n0 multiplied by 1 by 2 power 2, again divided by 2. That's all. It means here now I have 250 atoms, no? 250 atoms should become how many atoms? 125 atoms. So this equation how I can write? I can write n is equals to n0 multiplied by 2, 1 by 2 multiplied by 3. Okay. 3 half-lives, number of atoms is n0 into 1 by 2 power 3. Clear, no? So therefore, after nth half-life, okay, that is how much time? Time is equals to 4 into t power 1 by 2. Okay, so okay, ma? How can I calculate? N is equals to n0 power 1 by 2 whole cube divided by again 2, again half. So again how many? 125 divided by 2. 125 divided by 2 approximately 62.5. Clear, no, ma? So therefore n is equals to how much this one? n0. No, after n we are writing, no? So this will stop here. So n0 into, so directly I will write, no need of all this. I will write n is equals to n0 multiplied by 1 by 2 power, yeah, this is how I can write. Okay? Here also, instead of this one I can write. After nth half-life, so same sequence if I follow. So what will be the total time? Total time will be n into time taken for each half-life. Okay, ma? So therefore here also, if it is 3 half-lives, here in the numerator I got 3, no, power 3. So here I will get power, yeah. So this is the general equation to calculate number of atoms which are ready for disintegration after n half-lives. Okay. So n value, how can I calculate? N value is equals to, n value means what, ma? Number of half-lives. N is what? Number of half-lives. Okay. 3 means 3 half-lives, no? 2 means 2 half-lives, no? So n means n half-lives. And n value is how much? Total time divided by time taken for one half-life. Are you able to understand? So this is the equation to calculate, yeah, number of half-lives. Okay. So this is the beauty of radioactivity. Now see, listen very carefully. So initially consider 1000 atoms are present. Okay, ma? 1000 atoms should convert into 500 atoms. And let the time taken is 1 hour. So therefore 1 hour is nothing but half-life, no? What is meant by half-life? Time taken for 50% atoms to disintegrate. And the time taken is 1 hour. Okay, ma? So 1000 has become 500. Now 500 should become 250. Again half of the atom should disintegrate. Now what will be the time taken? Can you see? 1 hour only. 1000 atoms have converted into 500. It means how many atoms have disintegrated? 500 atoms have disintegrated. And time taken for 500 atoms to disintegrate is 1 hour. Clear? Now how many atoms are there? 500. From 500, 250 should disintegrate and 250 should be remaining. Then what will be the time taken? Half an hour, no? No. But the time taken is again 1 hour only. Okay, ma? Half-life always remains constant for that particular material. Are you able to understand, ma? So from 1000 to 500 also 1 hour. 500 to 250 also 1 hour, 250 to 125 also 1 hour, 125 to 62.5 also 1 hour. So this is how radioactivity behaves. So based on that logic only we have done this total calculation. Okay, ma? So to become from N0 to N0 by 2, time taken is 1 half-life. Okay, and N0 by 2 to N0 by 4, time taken is another half-life. So total half-lives 2 into 1 by 2. Time taken from 1 by 4th to become 1 by 8th, again half. Again time taken is 1 more half-life. Understood, Amma? This is how radioactivity will behave. 1000 నుంచి 500 వచ్చిన దానికి 1 hour, 500 నుంచి 225 వచ్చిన దానికి half an hour అని కాదు. Again it will take say 1 hour only. Okay, ma? So therefore to become 250 to 125 also 1 hour, 125 to 65.5 also 62.1 hour. This is called as half-life. Okay, ma? So write down. So 250 to again 125 also 1 hour. So 62.5 also 1 hour. Therefore what is the note point we have to write? Okay, ma? So for every half of the atoms to disintegrate, same time is taken. Same time is taken. This is the most important point in radioactivity. Are you able to understand? Clear now what is happening? So this is one very beautiful equation to calculate the number of half-lives or how many atoms are present after a particular number of half-lives. Okay? So write down one question. Write down one question. Question is, shall I rub this? A radioactive substance has a half-life of 16 days. Okay, ma? Find the fraction of atoms decayed after 64 days. That is the question. Okay, come on, try to do this question. Kota problems చేసేటప్పుడు. Okay, man, now see. So this is the given question. No, radioactive substance has a half-life of 16 days and find the fraction of atoms decayed after 64 days. Okay, man. So formula already we have studied now. N is equal to N0 power 1 by 2 power n. This already we have studied. Okay. And what is meant by n? Total time divided by half-life. This also we know. Okay. First of all, without using this one, let us proceed in the general fashion. See, so after 16 days, one half-life is completed, no? One half-life is completed. So if initial number of atoms are N0, then it will become N0 by 2. That's all, no? After one half-life, if original number of atoms are N0, half of the atoms have disintegrated and half of the atoms are ready for disintegration. Now, so after one more half-life, that is 32 days, 16 plus 16, 32 only, no? After 32 days, second half-life will be completed. And after second half-life, in this one, again half of the atoms will be disintegrated. Clear, no? So total they will become N0 divided by 4. Okay, ma? Are you able to understand? Now what is meant by N0 by 4? These many atoms are present for disintegration. Only these many atoms are present for disintegration. Are you able to understand, ma? So after 48 days, how you get this 48, ma? 32 plus 16, which means another half-life is completed. Then what will happen? Now third half-life is completed, no? Third half-life is completed. So it means N0 by 4 and in that one again divided by 2. So it will become N0 divided by 8. Okay. What is N0 divided by 8? Now only these many atoms are there which are ready to disintegrate. Remaining all the atoms have disintegrated. Even remaining atoms which are ready for disintegration. Are you able to understand? Now after 64 days, how many half-lives are completed, ma? 4 half-lives are completed. That is the fourth half-life is also completed. Now how many atoms are present? N0 divided by 8 divided by 2. So N0 divided by 16. Okay, ma? So these many atoms are present for డిసింటిగ్రేషన్. ఇవి ఉన్నవి, పోయినవి కాదు ఇవి. దీస్ మెనీ ఆటమ్స్ ఆర్ దేర్ ఫర్ డిసింటిగ్రేషన్. ఓకేనా? సో వాట్ ఈస్ n0 by 16? n0 by 16 is number of atoms ready for disintegration. Are you able to understand? Okay, ma? These many atoms are ready for disintegration. Now, so what he is asking, fraction of atoms decayed. So decayed atoms are how many, ma?
n0 by 16 minus.
Decayed atoms are how many? Can you say? Total initial atoms n minus remaining atoms n0 by 16. So total how much? 16 n0 minus n0 divided by 16. So total how much? 15 n0 divided by 16. So these are the decayed atoms. Ante kada? Out of total atoms, these many atoms are present for disintegration. Remaining all the atoms have disintegrated. What is the initial number of atoms? n0. How many atoms are present? n0 by 16. So original number lonchi ee number teeseste decayed atoms vastayi kada. So how many atoms have decayed? 15 n0 by 16 atoms have decayed. Therefore fraction, how can you calculate? Fraction is equals to decayed atoms by original atoms. That's all. No? This is the fraction. No? Decayed atoms 15 n0 divided by 16 divided by n0. n0 if you get cancelled, 15 by 16. So that is the fraction of atoms which have already decayed. Understood? చేస్తే వస్తుంది. అది అట్టగా సార్ ఇట్టగా సార్ అంటే వస్తుంది, ఏమి రాదు. ఓకే? So this is the general method of solving. Now if you use the equation, see whether you get the same answer or not. Okay? Equation కూడా ఉంది కదా, shortcut equation. Now let us proceed according to the formula. Which is the formula? Formula is, this is the formula, no? Okay, ma? See, ma. N is equals to n0 multiplied by 1 by 2 power n. Okay, this is the equation. No? What is n here? Number of atoms undecayed. This is n, no? Which means which are ready for disintegration. Okay, ma? N not means what? Original number of atoms. N means what? Number of half-lives. Number of half-lives. That is called n, no? So 1 half-life, 2 half-lives, 3. How many half-lives are gone? And what is the equation to calculate n? Total time divided by time taken for 1 half-life. All this we have done previously. No? What is the total time he gave? 64 years, 64 days. And what is the time taken for 1 half-life? 16. So 64 by 16 is how much? 4. It means how many half-lives have gone? 4 half-lives have gone. 4 half-life అయిపోయినాయి అని అర్థం. Are you able to understand? Total time is 64. Time taken for each half-life is 16. So 64 by 16, 4 half-lives are completed. Okay? So therefore, now substitute in this equation. So therefore, n is equals to n0 multiplied by 1 by 2 power 4. Okay? So therefore, how much? N is equals to n0 multiplied by 1 by 16. So therefore, n0 divided by 16. So same answer I got once again. Are you able to understand? And what is meant by n? N ante number of atoms which are ready for disintegration. And how many they are? They are only n0 by 16. So therefore, decayed atoms. Decayed atoms are how many? Chapandi. Decayed atoms. These are the left atoms. ఇవి మిగిలి ఉన్నవి. ఎన్ని లేచిపోయినాయి? Again same formula. Total number is n0 minus remaining is n0 divided by 16. So therefore, decayed atoms is how much? 15 n0 divided by 16. Therefore, fraction, how can I calculate? Fraction is a fraction of decayed atoms is 15 n0 by 16 divided by n0. So how much? 15 by 16. That's it. Same answer. Understood number? That's it. Very simple. అర్థమవుతుందా? So once again when you go through this problem. Okay, ma? Next. So this is the given question. Plutonium has a half-life of 24,000 years. Then what fraction of it will remain after 72,000 of years? Okay, very simple. Okay, ma? So 24 into 3 is 72, no? 24 3s are 72. It means that 3 half-lives are completed. That's it, no? 3 half-lives are completed. So therefore I can say 3 half-lives have completed. So therefore, if I write about general method of solving, first method of solving, okay, ma? So after 1 half-life, first half-life, how many atoms will be there? n0 divided by 2. Clear, no? After second half-life, n0 by 2 divided by 2, n0 by 4. These many atoms will be ready for disintegration. And after third half-life, okay, ma? So n0 by 4 divided by again 2. So total how much, ma? N naught by 8 atoms are ready for disintegration and will remain. It means this only now he is asking. So these many atoms are present for disintegration. That is my answer. N naught divided by 8. What fraction he is asking now? Fraction means what I will do? Fraction means N naught by 8 divided by N naught. So 1 by 8. That is my answer. That is the fraction of atoms remaining for disintegration. Okay. If I want to do in a second method by using equation. Okay. So number of half-lives are 3. How many half-lives? 3 half-lives. So substitute. So N is equals to N naught power 1 by 2 power N. This is the equation number. Okay. So therefore N naught multiplied by 1 by 2 power 3, N naught divided by 8. Okay. So therefore again fraction, how can you calculate? N naught by 8 divided by N naught 1 by 8. That is the answer. That's all. So 1 by 8 the fraction of atoms are still ready for disintegration. That is the meaning of it. Okay. So Sima, let us see this question. So half-life of a radioactive substance is 30 days. Okay. So half-life means one, we know half of the atoms to disintegrate and only half will be present. So further time taken is 30 days. So what is the time taken for 3 by 4th of original mass to disintegrate? Okay. It means 3 by 4th are the remaining atoms or are they disintegrated atoms? Disintegrated atoms. That's all. So therefore left atoms are how many? Left atoms are how many? 1 by 4th is a fraction of my original number. I can take 1. 1 minus 3 by 4. 1 minus 3 by 4 is nothing but 1 by 4. So 1 by 4th atoms are present for ready for disintegration. That is the meaning of this one. No? 3 by 4th of the mass has already disintegrated. So left mass is how much? 1 by 4. That's all. If original number, if I take 1, 1 minus 3 by 4 is 1 by 4. So therefore 1 by 4th mass is present. Are you able to understand? So in which condition you will get 1 by 4? Ma? Very simple. 1 converts into 1 by 2 after 30 days. That's all. 1 converts into 1 by 2 after how many days? 30 days. 30 days half-life already he given. 1 by 2 converts into 1 by 4 after another 30 days. So total time is, so that's all. Very simple. Okay. So very carefully you should read the question first of all, and then you have to identify what is the meaning of each word which we have written in the equation. Okay. Or if you want to solve according to the equation, how can I solve? Let us see. So n is equals to n naught power 1 by 2 power n. Are you able to understand? Number? So therefore n means what here? Number of atoms which are left, which are ready for disintegration. That is 1 by 4. Okay. So or you can write n by 4. N by 4 or n naught by 4. Original number of atoms n naught. So n naught by 4 are ready for disintegration. So this is equals to n naught multiplied by 1 by 2 power n. N naught you cancel. So 1 by 4 is equals to 1 by 2 power n. Okay, ma? 1 by 4 also can be written as 1 by 2 whole square, no? So 1 by 2 power n. So therefore what is n? N is equal to 2. That's all, no? What is n is equal to 2? 2 half-lives. N is number of half-lives only, no? 2 half-lives. Therefore 30, no? 30 plus 30. 60 days. Or you can say 2 into 30. 60 days. That's all. అర్థమవుతుంది కదా half-life ఎలా ఫైండ్ అవుట్ చేయాలో? Very simple. Sima. So see here, 10% of radioactive material decays in 5 days. That's what he gave, no? Then what would be the percentage of amount of original atoms left undecayed after 20 days? That's what he's asking, no? So this problem just you can do like half-life only. For first half-life, for example, consider 5 days. For next half-life also, 5 days. Are you able to understand, no? But after first half-life, 1 by 2 atoms, n naught by 2 will be there. That is 50% of the atoms have disintegrated. After second half-life, n naught by 2 again by 2, n naught by 4. It means 25% are remaining, 75% have disintegrated just after 2 half-lives. Same procedure you can apply here also. Okay, so let us see. So after 5 days, clear nama? So how much percent have disintegrated? 10%. It means remaining will be how much? Remaining will be 90%. That's all. Okay. 90%, how can I write? I can write 90 by 100 multiplied by n naught. Can I write like this? 90%. So after 5 days, that is after 5 days, 10% is disappeared, that is 10% have disintegrated, and 90% have not disintegrated. Okay. Now listen very carefully. After another 5 days, that is after total 10 days. Again what will happen? Again in the remaining number of atoms, again 10% should disintegrate. సో మీరు వాట్ యు ఆర్ డూయింగ్ ఈస్ 10 ప్లస్ 20 ప్లస్ 30 ప్లస్ 40% ఆఫ్ డిసింటిగ్రేటెడ్ కొంత క్యాల్కులేషన్లో చేస్తూ ఉన్నారు మీరు, అర్థమవుతుంది కదా. సో ఇన్ లెఫ్ట్ ఆటమ్స్ అగైన్ 10% విల్ బి డిసింటిగ్రేటెడ్. రిమైనింగ్ ఆటమ్స్ ఓన్లీ దిస్ మచ్, నో, ఇవే కదా మిగిలిన ఆటమ్స్. ఇన్ దిస్ రిమైనింగ్ ఆటమ్స్ 10% షుడ్ అగైన్ disintegrate. Okay, so after another 5 days again what will be the remaining number of atoms? 90% of this value, 90 by 100 multiplied by n naught, that's all. After another 5 days another 10% of remaining atoms have disintegrated. Disintegrate ayina vevi 10%, remaining will be how much? 90%. 90% of what? Remaining atoms. 90% of 90%, those are the remaining atoms, understand? So therefore how can I write? I can write again 90 by 100 multiplied by 90 by 100 multiplied by n naught. Clear nama? So 90 by 100 whole square multiplied by n naught. Okay, so total how many days completed ba? 10 days completed. So write down after another 5 days. After another 5 days, so total how many days? 15 days. Now what is the remaining atoms? Okay ma, the remaining will be how much? Again it is 90% of these atoms. 90 by 100 whole square multiplied by n naught, that's all. So therefore can I write it as 90 by 100 whole cube multiplied by n naught, that's all number. So therefore finally after 20 days, after 20 days, that means after another 5 days, definitely it should be 90 by 100 power 4 multiplied by n naught, that's all number. So this will be the remaining atoms. Okay, and if you do this calculation it is approximately 65.6%. That's all, that is my answer. 90 by 100 you can write 9 by 10, no? So do 9 by 10 to the power of 4, then this is the answer which you will get. You will get a fraction, no? Fraction you multiplied by 100, then this is what you will get. Okay, and if you want to do calculation here you can do. So therefore percentage left undecayed is how much? 90 by 100 whole power 4 multiplied by n naught multiplied by 100, so 65.6%, that's it. In half-life also this was the method we have followed, no ma? So for any percentage you have to follow the same method. Half-life is 50%. Here instead of 50% what he gave? 10%. But whatever it may be, calculations remain same. Okay? That's it. Okay. Na? So student ma. So next concept is average life or mean life. See ma here. So when a atom will disintegrate, we don't have any idea, no ma? According to Rutherford's law of radioactivity, when a atom disintegrates or when an atom doesn't disintegrate, we don't have any idea. So what we do is we take the average life of each atom present in a radioactive substance. And how can I calculate that one? Sum of lives of all atoms. For example, if 100 atoms are present, so what is the time taken for all the 100 atoms to disintegrate? Are you able to understand? Ma? Or if you say first atom is disintegrating after 3 hours, second atom is disintegrating after 100 years, anything can happen. So you take the sum of lives of all the atoms divided by total number of atoms. Then you will get average life only, no? Are you able to understand? Ma? It means on an average, after how much time an atom will disintegrate, that is called as average life. So sum of lives of all atoms divided by total number of atoms, average. Okay, and the relation between average lifetime and decay constant, this is the relation. T average is exactly equal to the reciprocal of lambda. Okay, similarly I want to calculate a relation between, okay ma, relation between T average and T half. So what is the meaning of this? Do I know? No? So T average means what? Average lifetime. And T1 by 2 means time taken for half lifetime. I want to derive a relation between them. How can I derive? Let us see. Okay, see ma here, T average is equals to 1 by lambda, no? Lambda can be written as 0.693 divided by T half life, no? Already we have written this equation, no? So substitute here. Therefore 1 by lambda value is how much? 0.693 divided by T half. Okay, so therefore T average is equals to T half life divided by 0.693. So therefore half life is how much? 0.693 multiplied by T average, or also you can write, here I will write down, 0.693 is nothing but log 2 to the base e, no? So T1 by 2 can be written as log 2 to the base e multiplied by T average. So this is the relation between half-life and T average. Understood? So these relations you should remember. Okay? These relations are meeku gurtundi. Okay. So the next concept which we are studying is activity. So what is meant by activity? Number of disintegrations per second is just called as activity. So already we have studied dN by dt previously, no? That itself is called as activity. Are you able to understand? So what is meant by dN by dt? Number of disintegrations per second is called as activity. Are you able to understand? So therefore Let us see, so A is equals to minus dN by dt, and it is directly proportional to n. Already we have studied it previously, no? Number of disintegrations per second depend on what? Initial number of atoms. If number of atoms are greater, more disintegrations will happen. Clear, no? So therefore I can write A is proportional to n. Okay, and we know that A is equals to lambda into n, no? This relation was written like this only, no? So minus dN by dt is equals to lambda into n. So here also I am writing lambda into n. So this is how I can write equation of activity. So activity is nothing but dN by dt, and it is equal to lambda into n. Okay. Then again what I can write is at t is equals to t naught. Okay, ma? Or when you say when t naught is equal to 0, that is at initial time. When you started observation, then activity I can write it as, then activity will be A naught. That's all, no? When you started observation, then at that time activity I can write it as A naught. And same equation how I can write at the same time, A naught is equals to lambda into n naught. I can write like this also, no? So this is the activity after some time now. Okay, this is the activity at a time, or after some time. After some time. Okay, and this is the activity initially. So therefore if you divide both of them, I can write A divided by A naught is equals to lambda m divided by lambda n naught. So lambda get cancelled. So A divided by A naught is equals to n divided by n naught. So this is one important equation. Okay, A means activity. A naught means initial activity. N means number of atoms ready for disintegration after some time. N naught means initial number of atoms which were ready for disintegration. Okay, and already we have studied that n is equals to n naught e power minus lambda into t. This already we have studied now. So take that and substitute here. So therefore A by A naught is equals to n naught e power minus lambda t divided by n naught. N naught you can cancel now. So therefore A is equals to A naught e power minus lambda into t. So this is another equation which gives relation between initial activity and final activity. Okay, no? So A is activity at present, that is after a time of t, and A naught is the initial activity before a time of t. So questions can be asked on this one also. Understood, Nama? That's it. Okay. Same relation I can write like this also, na? A divided by A naught. N, how I can write n naught power 1 by 2 power n also I can write in terms of number of half-lives. So divided by n naught. So n naught if they get cancelled. So A by A naught is equals to 1 by 2 power n. So you can write like this also. Or you can write A is equals to A naught multiplied by 1 by 2 power n. You can write like this also. Understood, Tama? Where n here, n is number of half-lives. N is number of half-lives. So write that also. Number of half-lives. So if there are 2 half-lives completed, then I will write n value is 2. 3 half-lives completed, I will write n value is 3, like that. Fine? That's it. Okay, ma? So next we are studying about units of activity, or unit of radioactivity. So the first one which we have to study is Curie. Okay, ma? 1 Curie is equal to how many disintegrations? 3.7 into 10 power 10 disintegrations per second. And what is meant by disintegrations? Already we have studied, no, ma? So if this many atoms are disintegrating in 1 second, then it is called as 1 Curie. Clear, no? And disintegration means what? Either emission of alpha particle or beta particle. If alpha is emitted, then also it is called disintegration. If beta is emitted, then also it is called as disintegration. Okay. Next, becquerel. So 1 becquerel is nothing but 1 disintegration per 1 second. Okay, ma? If 1 atom is disintegrating in 1 second, then it is called as becquerel. So obviously, I can write 1 Curie is equal to 3.7 into 10 power 10 BQ, because this many disintegration is called as 1 Curie. And what is meant by Rutherford? 1 Rutherford is 10 power 6 disintegrations per second. So these are some of the units of radioactivity, or you can call it as activity. Activity is also called as dN divided by dt, number of disintegrations per second is called as activity. Okay. Okay. So see this question, so calculate the kinetic energy and speed of alpha particle, okay, ma, emitted when uranium decays into thorium and when alpha particle is released. Okay. So see here what is the process which is happening, ma? So uranium 92 and 232, it is converting into thorium 90 to 28. This is what is happening, no? Clear, no? So what is happening to proton number, ma? Proton number decreased by how much factor? 2. What happened to mass number? Mass number reduced by 4, no? Clear, no? It means definitely alpha particle would have been released. That's all, no? Because the proton number or the charge of alpha particle is 2, and what is its mass number? Mass number is 4. So definitely this should have been the process which should have been done. Okay. So what he's asking, you are supposed to find out the kinetic energy and speed of alpha particle emitted in this condition. Okay. First of all, can you say how this alpha particle got this kinetic energy? Why this alpha particle should get energy? Just to release out the chalgada. But he is saying that after releasing, alpha particle is having some velocity also. That's what he is saying. No? So how this alpha particle got this velocity?
They got more energy than before.
How it got more energy? How it got more energy?
We provided.
We did not provide. This process is occurring naturally. Radioactivity nobody can force. Now already we have studied Rutherford's law of radioactivity. No? Radioactivity does never depend upon temperature, pressure or any other external factor. It should happen by itself. Okay, but they never control failure. Is it clear? So energy would have been obtained by alpha particle only because some mass should have been converted into energy. That is the only option which we have. Clear? Now see here, let us calculate mass defect. What is meant by mass defect? Mass defect means what? The amount of mass which has disappeared and converted into energy. That is called as mass defect. So calculate. What is the initial mass of uranium-92 232? It is given. No? So 232.03714 minus of. Clear number? So now it is finally converting into thorium and an alpha particle. So thorium mass is 228.02873 plus, and what is the mass of alpha particle? 4.002603. Clear? No? So if you do this calculation, then you will get the amount of mass which has disappeared. Understood? No? So let us see what is the value which he gave. So it is 0.00581. So 0.00581 million electron volts of energy has been, mass has been, this is in AMU's number, atomic mass units. Okay. So this much amount of mass has been disappeared. Are you able to understand? Now when this mass has disappeared, okay, now what is the energy that should have been released? Energy released, how can I calculate?
0.00581
into
9.
931.5. So previously we studied that if 1 AMU it is converted into energy. AMU is the unit of mass only, no? Mass, small masses, atomic masses we study in the case of AMU. So 1 AMU if it is converted into energy, then 931.5 million electron volts of energy will be released. Already we have studied, no? Clear number? So therefore do this calculation. So energy released from 0.00581 multiplied by 931.5 million electron volts. If you do this calculation, then you will get the total amount of energy which is released. Okay? Make a note. Okay, ma? So now see. So therefore this much amount of energy will be released. Ma. Let us see how much will be that energy. 5.4 million electron volts. Okay, ma? So this much amount of energy will be released. Okay. Now out of this total energy, can I say that this will be the energy of alpha particle? This is the total amount of energy is released. Can I say this will be the energy obtained by alpha particle? Can I say or not? I cannot say, because there are two products. Thorium atom is also released, alpha particle is also released. So some of the energy will be taken by thorium and remaining energy will be taken by helium also. Are you able to understand? So therefore thorium also will get some kinetic energy. Similarly alpha particle also will get some kinetic energy. Are you able to understand? So if I consider this total energy of Q, total energy if I consider to be Q, then what is the energy obtained by alpha particle? I can write like this. Okay, ma? So energy obtained by alpha particle. Okay. Alpha particle, there is a formula. And what is that one? It is A minus 4 divided by A multiplied by Q. This is the amount of energy obtained by alpha particle. Are you able to understand? What is meant by A there? A means mass number. So what is the mass number of uranium? It is equals to 232. And 4 is the mass number of what? Helium, nucleus, multiplied by Q. And what is meant by Q? Q is the total amount of energy released. Clear? So substitute the values and see what is the answer you will get. Clear? So therefore 232 minus 4 divided by 232 multiplied by total energy released is 5.4 million electron volts. So if you do this calculation, approximately it is 5.3 million electron volts of energy. That will be the amount of energy which will be obtained by alpha particle. Understood, Nama? Alpha particle will get this much amount of energy. Okay? Come on, make a note. Next we have to calculate kinetic energy also, Nama. Kinetic energy we have calculated. Speed now we have to calculate. So this is the energy taken by alpha particle, and energy will be always taken in the form of speed, kinetic energy of the alpha particle. Now how can I calculate this alpha particle will travel with how much speed? Can you say? How can I calculate? Speed ఎలా calculate చేయాలి? See, kinetic energy of alpha particle, already we have calculated now how much it is, 5.3 billion electron volts. And kinetic energy is nothing but half mv square, no ma? Kinetic energy is nothing but half mv square. So therefore, velocity is nothing but square root of 2 into kinetic energy divided by mass. I can write like this, no? 2 into kinetic energy divided by mass root, that will be the amount of speed of the alpha particle. Clear? That's all, no? Now substitute. So square root of 2 into, what is the kinetic energy obtained? 5.3 million electron volts. So I will try to calculate in terms of meters per second. So million is nothing but 10 power 6. Okay, ma? And 1 electron volt is equal to how many joules in SI system? 1.6 into 10 power minus 19 joules. Already we have calculated, no, ma? So 1 electron volt is equal to 1.6 into 10 power minus 19 joules. This is the amount of energy which is equivalent to 1 electron volt. Clear, no? So divided by, what is the mass of alpha particle, ma? Mass of the alpha particle already given, nearly 4 AMU. Okay, ma? So 4 into 1 AMU is again how much? 1 AMU is equals to 1.66 into 10 power minus 27 kg. That's all, no? So that value also I am writing here. 1 AMU is equal to how many kgs, ma? So 1.66 into 10 power minus 27 kg. So all the values I have substituted in SI system. So answer also I will get in SI system. Okay. So if you do this calculation, the answer which you will get will be in terms of meters per second. Okay. So the answer is 1.6 into 10 power 7. 1.6 into 10 power 7. 10 power 7 meters per second. That is my answer. Clear, ma? How we have calculated? Very simple. So just this formula you should remember, ma. Okay, ma? So let us see this question. So here what is happening is uranium 92-238, it is decayed into lead, plumbum 82 and 206. Clear, no? So already we have studied that plumbum 82, above this all the elements they are unstable. Only up to 82 only the elements are stable. After that the elements they are not stable. So uranium, after many decays, after continuously emitting alpha and beta radiations, finally it converted into plumbum 82 and 206. Then in this process, how many alpha particles will be emitted and how many beta particles will be emitted? That is the question. Clear, no? First of all, let us study about alpha decay. Okay. So when one alpha particle decays, what happens? Okay, alpha particle బయటికి వెళ్ళిపోతే ఏమవుతుంది? Proton number reduces by 2, mass number reduces by 4. So therefore, so atomic number reduces by how much? Atomic number reduces by 2 and mass number reduces by 4 units. This is what we have studied, because alpha particle is nothing but helium nucleus. Helium 2 and 4 is called as an alpha particle. So when one alpha particle goes out, so proton number reduces by 2, mass number reduces by 4. Okay. Next, what happens when beta particle goes out? When one beta particle is emitted, then what will happen? Come on. Atomic number increases by how much? Increases by 1 unit. Clear, no? And mass number? Mass number does not change. Okay. Mass number will never change when one beta particle is released, because already we have studied, no? How beta particle is released? One neutron, clear, no? One neutron converts into proton plus beta particle. So one neutron is reducing, but one proton is newly created, no? Okay. So therefore, one uncharged particle has reduced and one charged particle has increased. So therefore, definitely atomic number increases. But one AMU has disappeared, one AMU is created, so mass number does not change. This is what we have studied, no? So now see, now we will take this point into consideration and we will try to do the calculation. Okay, now see. So mass number never changes. So whatever may be the amount of beta particles which are released, 2, 3, 4, 5, 6, any number of beta particles, mass number never changes. So first you take mass number. Okay, ma? So uranium 92-238, it is converted into 206, no, ma? So therefore, what is the reduction in mass number? 238 minus 206 is how much, ma? 32. So this is the reduction in mass number. And mass number can reduce by what? Mass number దేని వల్ల తగ్గుతుంది? Only because of alpha particles. Beta particles never change the mass number. That's what we have studied. So therefore, alpha particles. So number of alpha particles, how can I calculate? Okay, ma? Definitely 32 divided by 4. 32 divided by 4 is how much? 8. 8 alpha particles are released. That's all, no? Because mass of each alpha particle, 4. 8 4s are 32. Reduction in mass number is 32 only, no? So definitely 8 alpha particles would have been released. That's all, no? That's it. Clear? Now let us calculate about how many beta particles are emitted. Okay. So when one beta particle is emitted, mass number increases by 1. atomic number increases by 1 and mass number does not change. Okay. Now if you take atomic number, okay, atomic number, are you able to understand? It converted into what? So it converted into 92 to 82. Okay. So therefore, now see how we can do this calculation. So 92 minus of how many alpha particles? 8 alpha particles. And with each alpha particle, proton number has reduced by 2, no? వినండి చాలా కేర్ఫుల్గా వినాలి. ముందే మన కోడి బ్రెయిన్స్, మనుషుకున్నంత బ్రెయిన్ కూడా లేదు, కోళ్ళకున్నంత మాత్రమే ఉంది. సో కేర్ఫుల్గా వినండి ఫస్ట్. సో 92 minus how many alpha particles are released? 8 alpha particles. And with each alpha particle, proton number reduces by how much? 2. So can I write 92 minus 8 into 2? That's all, nama. 92 converted into 82, nama. 92 converted into 82. So 92 minus how many alpha particles? 8. With each alpha particle, mass atomic number reduces by 2. And we are discussing about atomic number only, no? 92 is atomic number. So 92 minus 8 into 2. Because 8 alpha particles are released. And how many beta particles are released? I don't know. Let it be B. Okay, ma? And with each beta particle, one proton number will increase, no? If one beta particle is released, what happens to atomic number? Increases. So can I write beta into 1? Plus beta into 1. Minus 8 into 2, but plus beta into 1. Why minus 8 into 2? 8 alphas are released. So therefore proton number decreases by 2 for each alpha. But for each beta, what happens to proton number? Proton number increases. So plus I am writing. For alpha I am writing minus, for beta I am writing plus because it increases. And total should be how much? Total should be 82. That's all. From 92 I am removing this value and adding this value, then finally it should be 82. Now calculate beta value. Clear, nama? So therefore beta value is how much? Okay. So therefore beta is equals to 82 minus 92 plus 60. Clear, nama? So beta is equals to minus 10 plus 60. So how much? 6. So therefore how many beta particles are released? 6 beta particles are released. So this is the method of calculation. Are you able to understand? So first you proceed with that value which never changes. Okay. So mass number never changes, no? In which condition? When alpha particle is released, when beta particle is released, mass number never changes. Clear? So therefore in conversion from 238 to 206, the contribution should be only because of alpha. Because only when alpha is released, then only mass number will change. So change in mass number is only because of alpha only. Okay. Mass number మారిందంటే దేని వల్ల మారుంటుంది? కేవలం ఆల్ఫా వల్ల. బీటా మాస్ నెంబర్ని మార్చలేదు కదా. సో ఫస్ట్ యూ క్యాల్కులేట్ దట్ వన్, 8 alpha. Then you go for the atomic number. Then I can do very easily. Clear, no? And in changing atomic number, both will be helpful. So when alpha is released, then also proton number will change. When beta is released, then also alpha value will change. So in the second condition, I have taken atomic number and I have done the calculation. అర్థమైందా ఎలా చేసాము? That's it.